Yes, so we are back with another class, and today we are going to continue a little bit of hashing, and we are going to see hashing on strings. So today, once again, we are going to cover hashing, but we are looking at hashing specifically for strings. And there's one more thing that we are going to cover today, which is the Rabin-Karp algorithm, which is one way of hashing over a particular string. Right? This is for substring matching. Perfect. So let us begin. Let us start directly with a very simple question. The question goes something like this: that you have been given a string, let us say S. All right. Now you have to find whether it is possible to somehow permute or somehow rearrange the letters of the string B, somehow to permute or rearrange the letters of this given string so that it can be represented as a concatenations, a different, so that it can be represented as a different concatenations of some substring, of some string basically. So let us take an example perhaps. Suppose that I have the string AABB, right? So currently, if I look at this string, is this particular string a concatenation? So let us suppose that A equals to 2. Can I somehow break this string down into two parts such that both these parts are equal after rearranging the string? Yes, I can. Right? So if I currently this is not currently this cannot be these partitions are not equal. But what I can do is I can perhaps rearrange it like this: A B A B. Right? This string is just a permutation of this previous string. And now if I see in this string, yes, there are two occurrences of the exact same string. Is that clear? So basically, you will be given a string like this, and you will be given a number such as 2, and you have to tell me if it is possible to rearrange this original string such that it becomes a concatenation of A similar strings. I hope the question is clear. Right? So what approach can we come up for this particular question? Let us always begin whenever we solve a problem. We always try to begin with the absolute brute force approach, because as we know, being able to solve a problem is always the first step. Right? Let us forget about the optimizations. Let us do the optimizations later. Let us first solve the problem. So what will the entire brute force look like? Well, we know that we have a string, let us suppose S, and let us suppose the length of string S is N. So we can try all permutations. So let us suppose that we have some permutation of the string S. We have some permutation of the string S, and we have the value of A. We have the value of A. Let us suppose A is 4. So we can check, we can split this string into 4 parts, and we can check whether this is equal to this, is equal to this, is equal to this. Simple enough. That will be the brute force approach. What will be the time complexity of this approach? Well, first of all, how many permutations, how many solutions do we have to check through? How many permutations can be there in the worst case? If the length of the string is n, then the number of permutations will be n factorial. All right, and given a particular permutation, we will also have to check whether it satisfies this property. So that will take an extra order of n time per permutation. So the total time complexity will be order of n factorial times n, which is pretty bad, but at least we solved the question. Now, as most of you have already started pointing out, so Ashita is asking to repeat the question. So let me quickly repeat the question once again. So the question goes something like this: that we have been given a string S. We have been given a string S, and we have been also given a number A. Right? Now we have to check whether it is possible to permute or rearrange this original string such that it can be represented as a different concatenations of the same string. For example, if I have this string AABB, then currently I cannot represent this as two different concatenations of the same string. Right? Suppose that A has been given as 2. However, if I rearrange this string into ABAB, now I can say that, okay, because A is 2, I can represent this string as two different concatenations of the same string AB. Right? That is the question. And the brute force approach that we saw, that simply involved trying all the different permutations and checking each permutation separately, which was pretty slow, but at least it will give us the right answer. Right? This is the brute force. Now let us talk about the optimized approach. And yes, so both Vaishnav and Parth have given the right approach over here. So So has Akshat. Akshat has also given the right approach. Animesh, your approach is not quite correct. Right? So what the correct approach over here is? So what we can do over here is we know that this string S, suppose that this string S can be represented. Suppose for now that it can be permuted and represented as A concatenations of the same string. Then what can we understand from that? What can we understand from that? Let us suppose we break this down into A different parts. Suppose we break this down into A different parts. After the permutation, we know that this particular substring has to be the same as this particular substring after the permutation, right? And so on, this also has to be the same as this, and this also has to be the same as this. So what do we know? Suppose a character comes over here, right? Suppose this character is A. So we know that this character must also be over here, must also be over here, and must also be over here. Right? Similarly, if there's a character B over here, this is how the permuted string should look like. Right? Suppose there's a A over here and X over here. So this is what the permuted string should look like. Yes or no? All right. So what can we basically say from this? We can see that whatever character comes, right, for any character, right, the frequency of that character or the number of times that character occurs in the original string, that has to be a multiple of A, right? It has to be a multiple of A. Why so? Because if it is not a multiple of A, then you will not be able to make A different copies of it. You have to make A different copies of that same character to repeat that string. So it has to be a multiple of it. The frequency has to be a multiple of it. So this is very simple now, right? This is very simple. All we have to do is we have to go through the string, and maintain a count of each character. Right? Count each character, right? And then check for each character. Check if the frequency is multiple of A. All right. So this we have to understand over here that this must go both ways, right? This implication must go both ways. So we have so far established that if S has the property, then every character occurs some constant times A times. Right? That is what we have established. But that is not sufficient, right? That is not sufficient. We have to establish that the other way is also possible. That if you have any such string, then you can always rearrange the string into A different subparts that match, right? And that is actually pretty simple to see. What we can do is once we have, let us suppose that we have several characters C1, C2, C3, C4, right? And all these characters occur in some constant, let us say alpha times A, right? This occurs beta times A. This occurs gamma times A. This occurs delta times A. Right? Now, what we can simply do is we can start putting these characters in. Right? So we can put C1 alpha times. So this will be alpha times. Then we can put C2 beta times. Then we can put C3 gamma times, followed by C4 delta times. Right? So this particular thing will give us one part of the string, and then we can simply repeat this A times. And that will give us these frequencies that we so desire. Right? So we see that yes, this implication goes both ways. So this is both necessary and sufficient to solve our problem. Right? So the solution now becomes very simple. Just go through the string, count each character, and at the end we just have to check for every character if its frequency is a multiple of E. Perfect. Let us see some other approaches that we have. Sai is saying we first check if length of string is multiple of A or not. If it is, then we go with the solution, else returns false right away. Right? Yes. So Sai has a very nice optimization over here. Sai says that, hey, if the original string S, let us say the length of S is suppose 10, and let us suppose that A has been given to you as suppose 4. Now we know that no matter what you do, no matter how you commute or what substring you choose, if you have a string of length n, you cannot make 4 substrings out of it of the same length. Right? You cannot make 4 substrings out of it of the same length. Why? Because simply 10 is not divisible by 4. Right? 10 mod 4 is not 0. Right? So this is one check that we can very well do. At the start itself, we can check if the length of the string is a multiple of the value A. Only then should we continue with the rest of the solution. Otherwise, we can very quickly return false. That's a nice optimization. Thank you, sir. Perfect. So I hope that you guys will be able to code it. Yes. So how do you count the frequency of a particular character? Well, this is easy if I know what the underlying character set is. If I know that my string consists of only lowercase a to lowercase z, then it is simple, right? I just have a frequency array of size 26, right? One for each character. But what if I do not know? What if I do not know what the underlying character set is? Then I can use something like a hash map. And that hash map will take care of figuring out the underlying character set for me. It doesn't really matter what characters I see. So what will be the time complexity of this optimized approach? Let us suppose that we are using a hash map. And let us suppose that the amortized time complexity of checking or insert in a hash map is order of 1 amortized. Right? Or basically, let's not say amortized, let's say expected. So what will be the overall time complexity? Well, now we are just iterating through the string and counting the characters, right? And finally checking if each of the values is a multiple of a or not. So this is very simple, order of n plus, so n is the length of substring, plus order of delta, right? Delta is the size of character set. And we always know that size of character set has to be less than or equal to n, right? Because in the worst case, every character can be different. So I can just rewrite this as order of n. So that is the time complexity of the optimized approach. So what we see from here is that all these things are variants of hashing. Calculating a hash, so over here, our hash function was slightly different. Our hash function over here was just the frequency count of characters, right? And whenever we are solving problem related to hashing, we might have to choose our own hash function to make sure that it aligns with the problem that we are solving. So let us look at one more question perhaps. So suppose that we have been given an array. We have been given an array A of size n, and this array consists of n strings. So we have been given an array of n, and this array consists of n strings. We have to return the groups of all strings which are anagrams. Right? This is a very simple question again. So let us quickly understand the question. Suppose that I have an array that looks something like this. Right? So array is at, dog, god, right? Act, and fan. Suppose that this is my particular array. So over here in this array, if I rearrange the values, I can see that cat and act, they are anagrams. Right? So first of all, does everyone understand what an anagram is? Two words are anagrams. A and B are anagrams. If and only if A can be rearranged to look like B. Right? For example, the words dog and the word God, they are both anagrams because there is one G, there's one O, there's one D. I can rearrange them to look the same. Right? Now the question is that we have been given an array and we have to return the groups of all anagrams. Okay, so over here, if this was given as the input, then our output will be what? So let us quickly number all these values. So suppose this is 1, this is 2, this is 3, this is 4, right? This is 5. So our output should be a list of lists. Right? Our output should be a list of lists. The first group is 1, 4. Right? 1 and 4, they are anagrams. The second group can be 2, 3 because they are anagrams as well. And in the last group, I have 5 separate because fan is not an anagram with any of the rest of the strings. Right? So given this as input, we have to give this as the output. Is the question clear? Perfect. So let us once again look at the brute force solution. Right. In the brute force solution, what we can do is we can start with the first string. Basically the A of 0, and we can compare it with the rest of the strings. A of 1, A of 2, A of 3, A of 4, A of 5, and so on. Right? We can check each string with each of the other strings. While checking this string, we have to check for anagram. How do we really check for anagram? Should we try all the possible permutations? To check for an anagram? Not really, right? Is there any better way? So given two strings, we have to check if they are anagrams or not. Is there any good way of checking if two strings are anagrams or not? So suppose that we have been given a string A and a string B, and I have to check if A and B are anagrams. I mean, the brute force approach will be to check all permutations and compare. Right? That is very, very bad. So what we can do is we can otherwise check the frequency of each character. The frequencies have to match. And once again, if the frequencies match, then they are guaranteed to be anagrams. Right? Cool. We have another approach over here. So Ankush is saying that what we can do is we can simply add. We can simply add the ASCII values. Now this might not always give us the right answer. For example, suppose that we have the following strings. So we have A and D, and we have B and C. Right? So we know that the ASCII values of this is 65 and 69, and this is 66 and 67. Okay, so this is 68. Right? These are the ASCII values of these. And if we see, then yes, 65 plus 68, this is actually equal to 66 plus 67. Right? So if we were to compare these two strings by the ASCII values, by the sum of the ASCII values, then we will the solution will tell us that yes, these are anagrams, whereas these are not anagrams. All right. So something like this, something like a simple addition, is going to leave us astray. It is not going to give us the right answer. In many cases, it will give us the right answer, but you can always come up with edge cases. Right? So the correct way over here would be to count the frequency of each character, because that does not lose any information. Right? That saves all the information. Is there any other way? So yes, this is definitely a way. A simpler approach could be just to sort the strings. Sort the strings individually. Right? So for example, if I have the string God and if I have the string dog, if I sort God, then what string will I get? I will get DGO. Similarly, if I sort dog, I will get DGO. And the sorting strings, they have to match character by character. If I have two strings, and if I sort both of them, then the sorted value should be the same for the strings to be anagrams. All right. So what we can do is we can compare the string A0 with each of the other strings and check if it is anagram. If it is anagram, we will put it in the same group. But we are still comparing every string. We are still comparing A of 0 with all the other strings, right? Simply we are comparing A of A1 with all the different strings. So the time complexity of this is perhaps not that great. What will be the time complexity of this brute force solution? It will be pretty high, right? So we have to compare every string with every other string. So that is order of n square already. And we also have to check the anagrams, right? Suppose that we are using sorting to check if they are anagrams. So that will be an additional, let us say, not n, let us say k log k, where k is the length of the string. K is the length of the string. So no. So Shiv Kumar says that we can rewrite this as n cube. That is not correct, right? Because we cannot say that this is this is approximately n cube, because the length of the string is n, is k. Right? The length of the array, that is n. The maximum length of the string, that is k. The length of the array, that is n. Now this has not been given to us in the question. But we simply cannot assume that each string is going to be the same length as the size of the array. Right? That is not correct. We have to keep these variables separate. So that was one approach. Now once again, we can do better. Right? We can do better by using hash maps. So how should we hash the values? What should the hash function be? Suppose that I have this string s, then what should the hash of s look like? What hash function would I like to come up with? So that automatically, if I do hash by chaining, then automatically I get my answer. Yes, so Animesh has the right idea over here. Animesh says that let us store the sorted string in the hash map. So basically, given a string s, the hash of s will be the sorted representation of s. So now things become very simple, right? So if I have, let's say, cat, dog, god, act, and fan, what I can do is I can look at the first string. And if I sort this, I will get ACT. Right? For ACT, I will store the string. I will store the value 1, right? So this is index 1, 2, 3, 4, 5. Okay? And suppose that these are the indexes are starting by 1, right? So for act, I will store that, okay, this string is sorts to act. Next, I will move on to dog. So what is the sorted value of dog? That is DGO. So for DGO, I will store 2. Then I will come to God. The sorted value of God is also DGO. So for DGO, I will also store 3. Okay, then I'll come to act. So the sorted value of act is just act. So I will also store 4 over here. I will also store 4 over here. Finally, I will come to fan. The sorted value of fan is AFN. So for AFN, I will store 5. Right? And that will give us our correct answer. Do you guys agree? This is the final answer. So what we can do is we can sort each string and store it in a hash map, in a chain hash map. So this hash map stores. This hash map stores a string. So this is the key. The key is a string, and the value, corresponding value, is a list of indices, right? List of integers. Swapnil is saying, what if we take a map of size 26? It could be done in constant space. Well, Swapnil, you are assuming over here, that the underlying character set is of 26 characters. Right? That might not be the case. It might be the case that the underlying character set has all the Unicode characters. Right? It could be Chinese, it could be Kanji, it could be Devanagari, all these different characters, right? Prakash over here says, instead of storing string directly, we can convert each character of each string into a range 0 to 25 as frequency. Yes, so Prakash over here says that instead of sorting the string, we can do an optimization there as well. Sorting a string of size k will take us order of k log k time. This will take us order of k log k time, but we can do better. Right? So if we will come to that. So if we look at the complexity of this thing right now, the complexity is how much? We have to go over each string, right, and hash it. How do we hash it? We sort the string k log k. Right? So this is the current complexity. Now Swapnil over here, not Swapnil, okay, Prakash over here says that we can also optimize this k log k part. Right? Instead of sorting, we can keep the frequencies itself. We can keep the frequency of character. Right? That is one other way of checking for anagrams. Right? The frequencies should match. So in that case, our complexity will be reduced to an expected order of n times k time. And then what will our hash map look like? So our hash map will have to store what? So the key will be the frequency array. The frequency array of characters. So the key will itself be a hash map, basically. The key will itself be a hash map, or basically a frozen map. Hash map of frequencies, with character frequencies, and the corresponding value will once again be a list of indices. Right? Now, when you actually try to code this up, things might get a little difficult because using a hash map itself as a key can become tricky. Right? If you knew that okay, you had the character set of 26 characters only, then instead of storing the hash map of frequency, you could have just stored an array of 26 different values. You could have stored an array of just 26 different values, but you don't know what the underlying character set is. Right? So you will have to store a hash map, and hash maps are not usually hashable. So it is difficult to use hash map as keys. Perfect. Vignesh is asking, why are we seeing Rabin-Karp method over here? Well, Vignesh, Rabin-Karp method for string matching is just another very simple. I mean, it's not that difficult. It is just another hashing technique. And that is the next thing that we are going to come to. Perfect. Animesh says, what happens if the number of characters in a particular string is more than k log k? Well, Animesh, that is not possible. Right? So over here, k is the length of the largest string, of the longest string. Right? So if k is the length of the string, then it is not possible for the number of characters, in this string to be greater than k. Right? The number of characters has to be less than or equal to k. Yes, so Deepanshu over here is saying that if we go with this particular approach, if we go with this array approach, then the space complexity will be high. Exactly, Deepanshu. So suppose that our strings are Unicode strings. So how many different characters does Unicode have? Does anyone remember? How many different characters does Unicode have? Unicode has how many characters? It can support up to 65536 characters. Right? The number of characters in Unicode is huge. Right? So if we were to go with this array approach, if we were to store this array approach, then we will have to store an array of size 65536 for every string. That is very difficult. No, guys. ASCII has 256 characters. Unicode is much larger. Right? ASCII only has some English character, some English letters, some mathematical symbols, some accented letters, right, and some box drawing characters. But Unicode has a lot many letters. Okay, so this is not going to work, which is why we said that let us not keep an array. Instead, let us keep a hash map of the frequencies. But once again, if we are trying to keep the hash map, then things will get tricky because hash maps are generally not usable as keys. Vignesh is asking a very good question over here. Vignesh says, "Sir, I have a doubt. When we are doing competitive coding online, will the online judge also check the space complexity of our solution?" And yes, Vignesh, that is true. I mean, when you go to interview bit, when you go to Scalar Academy and interview bit, our online judge also checks the space complexity. Right? So we make sure that the memory that your particular program is using, the memory that is being used, we just monitor the memory that is being used, right? And this memory has to be within a reasonable limit depending on the programming language. So let us move on. I hope this solution is clear to everyone. All right. So the most optimized approach for this will be order of n times k. Right? If we do the hash map approach, so hash map of hash maps, it is not that simple. But otherwise, we can at least do it in order of n times k log k. Right? If we store a hash map of sorted strings. I hope that is clear. All right. Now let us move on to the Rabin-Karp algorithm. So far, in both the questions that we have seen, we were trying to come up with our own hash function. We were trying to come up with our own hash function so that we could simplify our life. Right? We could simplify our life. Now, Rabin-Karp algorithm is another such algorithm. It is basically used for string searching. String searching. So let us quickly define what the string searching problem is. Right? So the string searching problem is very simple. You have been given a large string S. Right? This string could be, let us say, a book, or this string could be Wikipedia, the entire text of Wikipedia, or this string could be the entirety of internet, perhaps, or this string could be all the products on Amazon. Right? It could be any such thing, and you have been given a pattern. Let us say the pattern looks something like abracadabra. And you want to figure out, first of all, you want to figure out whether this pattern exists in my string. Right? That is one of the most important things that we do while we are searching. But more importantly, I need to find where exactly. Where exactly. So suppose that I have this string over here. I have a large string over here. And suppose my given pattern appears over here, appears over here, appears over here, appears over here. Then I should be returning the starting indices of all these different occurrences. That is what the string search problem means. Given a large string and a small search pattern, search for that pattern in the entire string and report all the occurrences of that string. We have to report all the occurrences of the string, not just one occurrence. So, what is the normal way? What is the usual, most trivial way that you can solve this particular problem? Suppose that I have a string S of size n and I have a pattern P of size m. Then how should I particularly go about searching for this pattern in the string? I can use some sort of a sliding window. Right? I can use some sort of a sliding window. So if I have this string, I can first check this particular thing for the pattern match. Then I can shift by one character and then check this particular string for the pattern match. Then once again, I can shift one character and search this string for the pattern match, and so on and so forth. Right? So I can keep a window of p size and I can slide it. One character each. I can slide it right, one character each. So how much time will this take? Well, let us look at the first window. So we are currently matching this particular portion of size. So we will have to verify each of these characters, right? That this matches this, this matches this, this matches this, and so on till the end of this. So each check will take us order of p time. And how many checks do we have to perform? How many checks do we really have to perform? We have to start from this index 0 and we can go up till the index n minus p minus 1. Right? Because this last character will be at location n minus 1. So this is the last occurrence where the pattern p could occur. So it will be p times n minus p minus 1, which is simply order of n times p. Yes? No, now this np is not that p versus np thing. Right? This np is not that. This np is just the string length of the strings. Now the question is, can we do better? Can we do better? So there are many string searching algorithms. Today we are going to discuss Rabin-Karp, but in the coming classes we will discuss more complex string searching algorithms. Right? So you can search string using tries, you can search string using automatas, you can search string using n different ways, and we will be covering most of them in the coming classes. But today we are going to talk about the Rabin-Karp algorithm. So the Rabin-Karp algorithm has one special insight. Right? The Rabin-Karp algorithm says that, all right, let us suppose that you have this particular string. Let us suppose that you have this particular string and you are matching for this particular pattern, P over here. Right? You will spend some time, you will spend P time to check if this is a match or not. Yes or no? You will spend P time to check if this is a match or not. Now, when you move this to one right, when you move this to one right, now once again you will spend P time to check if it is a match or not. Yes or no? That is what is going to happen. So can we improve this? Can we somehow reduce this time complexity? So what Robin said, what Robin and Cobb said was that, all right, instead of comparing the strings, let me instead compare the hashes. Let me instead hash the strings. Let me hash the strings and let me compare the hashes. Right? So suppose that we have this particular part of the string, right? And we have this string that we are looking for, P. So if, let me call this string S dash, right? Let me call this substring S dash. So if the hash of S dash is not equal to the hash of P, right? If I have this hash of P, and if I looked at the hash of this, S dash, right? If I looked at the hash of this S dash, and the hashes do not match, then what can I say? Can this be equal to P? Can this substring match the same? Can this substring be the same as the pattern? No, it cannot be. Because if it is same as our pattern, then the hashes will have to match. So if the hashes do not match, then we are guaranteed that not a match. But if the hashes are equal, then what can we say? Can we say that yes, there are a match? Well, not really. Right? That depends on the hash function. Depends on the hash function. So basically, if the hash function is lossy, or basically if the hash can have collisions, then a matched hash means a match may be possible, right? A match might exist. Right? It is not necessary for the match to exist because it could just be a simple hash collision. On the other hand, if the hash function is lossless, or that is, it is guaranteed to have zero collisions, then yes, a match is same as a match exists, necessarily exists. So depending on our hash function, we know that yes, if there is a match, if the hash functions match, then an actual match might exist or might not exist. But we are at least sure that no matter what the hash function is, if the hashes do not match, then it is guaranteed that the substrings do not match. All right. So what can we do over here is, once we are trying to compare this particular substring for the pattern P, right? If we choose a hash function that has a certain property, so there's something called rolling hash functions. There's a certain property of a rolling hash function. The property is that once you have computed a hash of this thing, if you have to shift it by one character, then you can easily do it. You can easily calculate the hash of this thing in order of one time. Does that make sense? If you have the hash of P, the hash of, let's say, the index I all the way to I plus P, right? Then to compute the hash of I plus 1 all the way to I plus P plus 1, right? You can do this in just order of one time. Provided you have this previous hash. Right? Provided you have this previous hash. All right, but is this idea clear? That if we use a rolling hash function, then we can perhaps optimize our time complexity. Now let us have a quick look at one example of a rolling hash function. Right? So this is not the hash function used in Robin-Cobb. Right? Hash function. But this is one just example of a rolling hash function. Suppose that we simply add the ASCII values of the characters. First of all, as we saw that this particular hash function can have collisions, right? So this is not a perfect hash function. Yes, we just saw that what sort of collisions can happen. Suppose I have the string A and D and I have the string B and C, then the hash of AD will be equal to the hash of BC. Right? If my hash is just the sum of ASCII values, because this will be what? This will be 65 plus 16 or 68, and this will be 66 plus 67. Right? Both will have the same value. However, this is a rolling hash function. So suppose that I have this string. Let me call this A, B, C, D, E, F. G, right? I have the sum of these, right? So I have 65 plus 66 plus 67 all the way till some value, right? Let us say 72. Okay. Now if I have the hash of this, if I want to calculate the hash of this, perhaps some character over here. If I have to calculate the hash of this, then what should I do? Should I start once again from B? Should I start adding once again from B? I need not. I need not do that, right? Suppose this value was S. Suppose this value was S. Now I can just do S plus the code of alpha minus the code of A, right? I can just do this previous sum. I can add the code for this and I can subtract the code for this. And I can very simply calculate the hash function of this entire chunk. Yes, how much time will that take? That will take order of one time only. A rolling hash function is a function such that in which it is very simple to calculate the hash of the next substring once you have the hash of some substring. Yes, so Vignesh, yes, this is similar to sliding window sum. Right? This particular thing is similar to sliding window sum. However, this is not the hash function that Rabin-Karp will use. Right? This is not the hash function that Rabin-Karp will use. This is just an example of a rolling hash function. Right? So we will come to the decision of which hash function to use later on. We will come to the decision of which hash function to use later on. Let us first see that once we have this, what will be the time complexity of our total overall algorithm? What will be the time complexity? So I have this large string S of size n, right? And I have some pattern P of size n. So what I am doing is I am hashing. So first of all, I will calculate hash of P. How much time will that take? That will take me order of m time. Yes, because I have to calculate the hash of P. That will require going through each of the characters. Now I will start matching from here to here. Right? I will start matching from here to here. I will calculate the hash of this thing. I will calculate the hash of these things and I will check if the hashes match or not. If the hashes do not match, if hash does not match, then what will I do? I will slide right. I will slide my window to the right. And how will I slide my window to the right? To calculate the hash again, I will remove the value of this thing. I will remove the value of this thing and I will add the value of this thing. Right? And that will allow me to recompute the hash of this particular substring. Yes? So recomputing the hash will take me order of one time. So sliding right will take me just order of one time. Right? If the hashes do not match. But if the hashes match, if hashes, basically else, now what can I say? If the hashes match, as we just saw, that depending on the hash function, it is not guaranteed that the pattern exists, right? Because it could just have been a collision. It could just have been a spurious match. In that case, what do I do? In that case, I have to verify if my match is correct or not. So else verify. Else verify. How do I verify? Verification is very simple, right? I look at the first character, second character. I check if all these characters match. Right? Suppose my hash was same. Just to confirm that the string is actually the same, I can compare it letter by letter. So verification takes me order of m time. M time, where m is the length of my pattern. Perfect. And so this is part of the inner loop. This is part of the inner loop. This is code of the loop. And how many times are we repeating this? We are doing this for every window. Right? We are doing this for every window. And how many windows are there? There are order of n windows. Right? There are order of n windows. So basically what will happen is our time complexity will look something like this. If hashes do not match, so basically if there are no collisions, then what will happen? If there are no collisions, then every match is a guaranteed match. Right? Every particular match is guaranteed to be correct. Right? On the other hand, if there are collisions, if there are a lot of collisions, then every match, most of the matches will be spurious. Right? Most of the matches will be spurious. So can someone tell me what will be the worst case and best cases of this algorithm? So if there are no collisions, what will be the time complexity? Well, the time complexity will just be order of n. Right? The time complexity will just be order of n plus m, because if there are no collisions, then I'm guaranteed that as soon as the hash functions match, I'm guaranteed that the pattern exists. I don't have to verify it. If the collision possibility was not there, then this verification step is unnecessary. I don't really have to do that. Because every hash function match is guaranteed to be a pattern match. But if there is a chance of collision, then I have to do verification again and again and again. I have to keep doing verification. So in the worst case, as we see from this loop, this loop can go order of n times order of m. Right? So the total time complexity over here can be order of n times m. Right? And this time complexity, as we see, this is no better. this is no better than the brute force. If you look at the brute force solution, then the brute force solution was just order of m times n times p, right? So it is no better, Rabin-Karp is no better if the hash function has a lot of collisions. So the entire functionality of Rabin-Karp, the practical performance of Rabin-Karp will be based on whether you choose a good hash function for your use case or not. Alright, so Rabin-Karp basically, best case with perfect hash. This will take us order of n plus m time. Right? But in the worst case with imperfect hash will take us order of n times m time. Right? Now the question arises, what hash function should we use? Right? So can someone come up with a nice idea of a hash function? Well, we would want the hash function, to be as lossless as possible. We want to retain as much information about the string as possible. For example, if we have the string ABCD, if we add the ASCII values, are we retaining a lot of information? We are not necessarily retaining a lot of information, right? Because the hash of this is the same as the hash of DCBA. Right? So we are not retaining a lot of information. So this is a very lossy hash function. What will be the perfect hash function? What will be the completely lossless hash function? Well, I can encode each string into an integer. Right? I can actually encode each string into an integer, right? Because every string, when we look at it, every string is just stored as bits and bytes in the memory. Right? Everything in the computer is just zeros and ones. So I already know some way of encoding a string into an integer. Right? But if we are not sure how to encode the string into an integer, I can manually do it. Right? Suppose that my character set was ASCII. ASCII can have 256 different values. Right? ASCII can have 256 different values. So I can just treat this as a number in base 256. Right? I can just treat this as a number in base 256 and convert that number into base 10. What is this number equal to? So what is D? D is 97 plus 4. Right? That is D. So this is 101. The ASCII code of small d is 101 times 256 to the power 0. Plus, what is C? It is 100 times 256 to the power 1. Plus B is 99 times 250. Okay. I guess I messed up. This is 100, this is 99. This is 98 times 256 to the power 2 plus 97 times 256 to the power 3. Yes or no? This is how I can make sure that I have the entire information of the string. If I have this hash function, then it is guaranteed that there are no collisions. Right? Because I'm not losing any information. I'm just encoding that string. I can go from here to here and I can go back. Right? So there's no loss of information. But would this hash function usually work? Is it possible practically to use a hash function like this? Not really. Because these hashes can get arbitrarily large. Right? Suppose that my pattern is of size 50. Right? My pattern has size 50. Right? So in my pattern, this character, the ASCII value of this character will be multiplied by 256 to the power 50. That is ridiculous, right? That is a huge number. So I cannot possibly store this in a 64-bit integer or even a 128-bit integer. Right? That is not possible. So I have to reduce the size of the hash. Right? I have to reduce the size of the hash. And one common way of doing that is to just take a mod. Right? Mod or modulus. Yes. What should we usually take a mod by? Well, we can try to take a modulus by the size of our hash. Right? Suppose our hash, we can store 64-bit integers as hash. Then we can simply mod it by 2 to the power 64 minus 1. Alright, we can simply mod it by 2 to the power 64 minus 1. Alright. Usually it is still a better idea to use a large prime number for modding. Right? Because if you use a prime number, it has a slightly better distribution for the hashes. Perfect. So Rabin-Karp says this. Rabin-Karp just says this, that given a particular string, if you are trying to find a pattern, first of all, find the hash of the pattern. Right? And this is the hash. Hash is just the encoding of the pattern. Hash is just the binary encoding of this pattern, right? With some modulus. with some modulus m, right, with some large prime number p. Is that clear? Once you have calculated this hash, then compare the hash of each substring. Compare the hash of each substring with this hash. If it is not a match, then simply slide the window to the right. If it is a match, then please go and verify. Right? Please go and verify. Now, is this particular hash function rolling hash function? Suppose that you have the hash value of this, right? So you have A, B, C, D, right? And let us say that the character set is suppose 256, right? So this is 256 to the power 0, D times plus. So let me just rewrite this. This is just D times 256 to the power 0 plus C times 256 to the power 1 plus B times 256 to the power 2 plus A times 256 to the power 3, right? Where A equals to 97, B equals to 98, C equals to 99, and D equals to 100. So this will be my actual encoding, and I will also mod this with some value. Let us say M. Okay, this is the Rabin-Karp hash function. Is this a rolling hash function? Is this a rolling hash function? Basically, if I add a new character over here, E, suppose 101, then can I calculate the hash of this part? Can I efficiently calculate the part of hash of this part? Well, yes, I can. Yes, I can. Let us quickly see how. So what is the hash of this part? Right? Let us see. Let us first write what the hash of this part is. The hash of this part is this: B times 256 to the power 3 plus C times 256 to the power 2 plus D times 256 to the power 1 plus E times 256 to the power 0. This is the hash of this BCDE. All right, let us see if we can convert this, if we can somehow get this value from this value. All right, so first of all, what we will need to do is we will need to subtract the value of this. So what we can do is, first of all, from this we can subtract A times 256 to the power 3. Now, whatever remains, so what part will remain? This part will remain. Right? This part will remain. But we see that this part has one less part. Right? So currently B is being multiplied by 256 square. We need B as 256 to the power 3. Similarly, D has been multiplied by 256 to the power 0. But we need D multiplied by 256 to the power 1. So we just multiply the remaining thing. With the base 256. Right? And then we just add this last value. Then we just add this E times 256 to the power 0. That is going to give us the new hash function. Right? This is the same as binary. Right? If you have this binary number, and you know the base 10 representation of it, or if you have the base 10 representation of it, then you can remove this and add something over here, right, to get a new particular value. That is perfectly valid. You can totally do that. Right? So this is what the Rabin-Karp hash function is, And yes, this is a rolling hash function. Right? Now, there's one catch that you have to understand over here, that because this is a modulus, this is going to work. Right? Basically, do you guys know that modulus distributes over addition equals to A mod M plus B mod M? Right? So notice that there is some loss of information happening over here. Right? Once you have calculated this, after that you are losing some information because of this mod. Right? But that doesn't really matter, because modulus distributes over addition. It also distributes over subtraction. So notice that we have to subtract this value, but we can do that because we are using mod. Similarly, we have to multiply this value, and modulus also distributes over multiplication. The only reason we can do this is because we are using the modulus operator. We are losing information in a manner that mathematically makes sense. If we had lost information in some other manner, we would not have been able to reconstruct it. Right? We would not have been able to have the rolling hash property. Perfect. So this is basically it. This is the Rabin-Karp algorithm. So this was just some string matching using the hashes. Perfect. Surit says, are we not going to do a modulus on the next window? Yes, we are going to take a modulus on the next window as well. Right? So after we have done this, so basically, we have the hash. We have the hash of previous window. Right? Let me call this H. So what we are essentially doing is we are saying H minus what was the first character? Right? Character 0 times base to the power the length of P. Right? Base to the power length of P. So we will subtract this. Then we will multiply the result with the base, right? Then we will add what? We will add the new character. Character, let's say, call this new, and let's call this character old. We'll add new character, and then we will once again take the mod with the same value m. Length -1. Yes, my bad. Length -1. Thank you for that, Rajiv.
Okay, so guys, till now we have studied what is hashing. We have also studied an algorithm for string matching using hashing, right? Okay. Now, when we talk about strings, there is a vast majority of problems based on strings which can be solved using hashing. Okay, so hash map is a very powerful tool when it comes to solving problems of strings. Okay, so we are going to study a few problems today. We will be solving some problems based on strings which can be solved using hashing, and we will also be solving a problem which will involve some other techniques. But majority of the problems can be solved using hashing. Okay, so let us start the class with a very easy type of a problem. Let us say that you are given a string. Okay, let's say that this string is interview bit. Okay, you have to find what is the first non-repeating character. Okay, first non-repeating character means in the given string, some characters might be repeating, some might not be repeating. So which is the character, which is the first character which is non-repeating? Okay, so in this case, we can see that I is a character which is repeating in this string. So this is definitely not going to be an answer, right? N is actually the first non-repeating character because there is no N after this N, right? So N becomes the answer for this case. Okay. Let us take another string. For example, let us say scalar academy free classes. If this is the string, what should be the answer? If this is the string, we can see that S is repeating multiple times in this string, so S cannot be the answer. C is also repeating. C also cannot be the answer. A is also repeating. L is also repeating. Okay, E is also repeating. R is also repeating. Okay, D is the answer, right? So in this case, D becomes the answer. Okay, Scalar Academy free classes. D is the first non-repeating character in this string. Okay, so we'll quickly discuss the solution. Okay, there are no white space. Okay, you can assume that there are no white space in this string. Okay, this string has no white space. Okay, so what is the minimum information that we need to return this answer? The minimum information that we need is, first is that I want, so I will just write what is the info needed. Okay, first thing is, since I want to find first non-repeating character. Non-repeating character means a character which is occurring exactly one time, right? A character which is present in this string exactly one time. So the first information that I need is what is the count of all the characters in the string, right? So what is the frequency of each character? Because only if I have the frequency of each character, then only I can comment whether the characters are coming one time or multiple times, right? So this is the basic info which is required. The second basic info is, since I also want the first non-repeating character, so this information will give me which all characters are repeating, which all are non-repeating. For solving this problem, I also want which is the first such character. So I will also have to check the order, right? The order of character in which they are appearing in this string, right? So now, how can I compute the frequency of each character? Is there a very easy way to do that? Right, you can use a hash map, right? Or you can even use an array of size 26. That will also suffice, right? You can use an array or maybe a hash map for each and every character. If you are using an array, index 0 will correspond to the frequency of character A, index 1 correspond to the frequency of array B. So if this is a string of only, let's say small case characters, then you can use an array of size 25. If you are including each and every character, then you can use an array of size 256. Or what you can do is you can have a hash map. Both of them are same thing. So a hash map of character and integer. Okay, this will also suffice. Now once you have a hash map or maybe a map array, what you can do is you can iterate over this array, iterate over this string, and you can count the frequency of each and every character, right? So let us say that A, B, C, A, C, B, D, E. If let's say this is the string that we have, okay. Now if I am if I want to build a hash map after I iterate over this array and keep the count of frequency of each and every character, I will have something like this, right? A, B, C, D, E. All the unique characters will become the key, and corresponding to each and every unique character will be having a count. Right? So against A will be having 2, against B will be having again 2, C is also 2. Let us also have F and G. Okay, then and another C. Okay, so C, count of C will be 3. Count of D is going to be exactly once. Count of E is 2 for F1 and G1. Right. So now we have got the frequencies of each and every character. Okay. Now what is the second information which is needed? The order of the characters, right? So now after building this array, we know that these are the characters which are appearing exactly one time in this string, but we want to return the first such character. So how can we return the first such character? We need the order. Do we have the order already? Yes, right? We already have the order stored in this string. So again, we can iterate over this string, and we can check for each and every character, right? So if you again iterate over this string, you can check character-wise character whether this character is a character with single occurrence. No. So A is removed. Then you go to B. B is also not occurring exactly one time. C is also not occurring exactly one time. A again is not occurring. C can be skipped. B can be skipped. Then when you come to D, you see that D is such a character which is occurring exactly one time, and this is the first character that we have seen till now while iterating the string from left to right? So D becomes the answer. Okay, so how are we going to solve the problem? First we build the frequency array, or first we build the frequency hash map, and then again we iterate over this string, and character by character we check whether this character is a single occurring character or multiple times occurring character. If it is a single occurring character, we just return this. Okay. Now some of you are suggesting that taking XOR can solve the problem. No, taking XOR cannot solve the problem, because it is not guaranteed that all the other characters are occurring even number of times, right? So XOR is not going to cancel each and everything. In this case, if you can just take what is the XOR of this, so A and A will cancel out, B and B will cancel out, right? E and E will cancel out, but then you will be left with the XOR of C, D, F, and G, and you don't get any useful information from here, right? So XOR is not going to solve this problem. Then second option that is proposed is, can we do it using sorting? Shubhadeep, if you sort the if you sort the characters, you lose the order, right? But you need the first non-repeating character first in this given string. So sorting again cannot solve this problem. You will have to solve this problem using this way only. Okay, is this clear to everyone? Okay, let us solve another very interesting problem. So now you guys should keep an eye on this thing, that how hash map is enabling you to solve this problem very easily, right? Okay, let's move on to the next problem. The next problem says that you are given two strings, okay, and you have to tell whether the strings are isomorphic or not. So you are given two strings, you have to check whether the strings are isomorphic or not. In the context of this question, the meaning of isomorphic is that if you replace each and every character of string A by each and every character of string of the second string, you get the same string. Okay, so right, so there has to be a symmetry between these two strings. For example, if I have a string add and another string egg, right? So now if I just replace A by E and D by G, I get the second string. Okay, there has to be a symmetry between them. By symmetry in this case, we mean that there has to be a one-to-one mapping between the characters. Okay. So can I say that ABC is isomorphic to X, Y, Z? Is this correct? Yes, this is correct, right? Because you can replace A by X, B by Y, and C by Z. This is absolutely correct. Okay. Let us take another example. If I say that I will have, let's say, ABB replaced by CAC. Is this correct? So in this case, I can replace A by C, then I can replace B by A, but to make it correct, I will have to replace B by C for the third character, right? But we already have a mapping for B, which is A. So I cannot have another mapping for B. So this is wrong, okay? So now is the problem clear to everyone? You have to have a one-to-one mapping between the characters of string A to characters of string B. Two hash maps for each string and their character frequency. Okay, Azim, do you need the character frequency here? Map of character string with each other. Yes, Akshat, that will work. But do you need a one-way mapping or a two-way mapping? First, check if strings are of same length. Okay. If they are, use a hash map and check if it's already there in the map. Sai Kiran, you are saying that you will build a map or character to character map, right? If that is the case, then it's correct. Can we take ASCII difference between two strings? Heyman, just take some examples and check if that is going to work. Dictionary with each character mapping. Okay, Vignesh, that is in the right direction, but will that solve the problem? Okay, now the most commonly sent approach that I can say is that take a hash map, which is a character to character hash map. And in this hash map, we'll be keeping a mapping of characters of string A to characters of string B, right? So the key is going to be the characters of string A, right? So let's say that if I am creating the map for these two strings, I will map A to C, then I map B to A, and every time when I'm adding an entry to the map, I always check whether that key is already present or not. So when I add the last mapping, which is B to C, I see that B is already having a mapping, so I can return false. You can directly have a mapping of characters of string A to characters of string B, and while entering the mapping or while inserting the mapping in the hash map, you can just check whether the key is already present or not. If the key is already present and if the mapping is different, then you can return false, right? I can see it's clear to most of you, but is it correct? Let's take an example. What if I have string A is AB, second string is AA, right? What should be the answer for this case? Should it be true? Should it be false? This should be false, right? Because I am having a mapping from A to A. And then since this A already has a mapping with A, it cannot have a mapping with B. So this should be false. But if we go by this approach, what we will do is we'll put a mapping A to A. And then the next mapping that we are going to put is B to A. We will check the key. Key is not present, right? A is a different key, B is a different key. So we will insert this mapping as well. And according to our approach, this is going to give a right answer, which is wrong. So what do we need to do? We need to see whether there exists a one-to-one mapping. What does one-to-one means in terms of functions? One-to-one means that if A is mapping to this character, A should have exactly one mapping on the right side. And this character should also have exactly one mapping on the other side. So what we'll have to do? we'll have to keep both the mappings, right? So one hash map is not enough. We'll have to have two maps to store both the mappings, right? So both directions should be stored. So what you will be doing is you will be storing A to A. Simultaneously, you will also be storing this reverse mapping. Then you enter B to A, and then the reverse mapping is A to B. Now here you will see that this key is already existing, so this is not possible. So both of them are important. Okay. Why do we require two hash maps? Because in a single hash map, to check whether A is a value of any other key or not, you will have to iterate over each and every key, right? That is why that is not optimal, and hence we can use two hash maps to store both directions of mappings. Okay, cool. So now I think you should be getting a feel of how to solve string problems using hash maps or maybe using arrays of constant size, right? What is the time complexity here? What is the time complexity of this problem? So we are iterating all the both the strings exactly once, right? And then we are putting in the map, and then we are checking in the map. So whenever you use a map, especially if you are using an unordered map in C, or if you are using a hash map, we assume that the average time complexity of insertion or lookup in the map is order 1, right? So going by this assumption, the time complexity of this problem is nothing but order n, where n is the string length, the minimum out of the two strings. Okay. Will we code these problems on some code editor? Shrestha, you can code, or like there is an assignment based on strings as well. You can also attempt that assignment. Some of these problems are there in the assignment. Okay. Okay, let's move on to the next problem. Will this logic work for ABB and BBA? Yes, Pratyusha, check it yourself. Will this work or not? You store a mapping from A. So what Pratyusha is asking, she is saying that there is a string ABB and then BBA. Okay. So you store a mapping from A to B. Simultaneously, you store another mapping from B to A. Right. Then you store a mapping from B to B in this map. And here again, you try to store the mapping from B to B, but you check that this key is already present with a different value. So this is going to fail. Okay. Okay, let's move on to the next problem. The next problem says that you are given a string and you have to remove pairs of duplicate characters placed together. Okay, you remove pairs of duplicate characters placed together. For example, what do we mean by this is, let's say that this string is A, B, C, C, D. So now we can see that this is a pair of duplicate characters and it is placed together, which means that these two duplicate characters are placed next to each other. So you have to remove them. So the output that you are going to get is going to be A, B, and D. Okay. Then the next example could be that A, B, C, C, B, D. Okay. Not D, D. It should be B, D. Okay. If this is the question, then first what you do is you remove these two. Okay. So let me add something extra here. You have to recursively remove. Okay, recursively remove pairs of duplicate characters, which means that here if you remove C and C, then the string that you get is A, B, B, D. Now even in this string, B and B forms a pair of duplicate characters. So you will have to remove this as well. So the final output is going to be A, D. Okay. In some of the cases, it might be possible that you will have to return an empty string. For example, if you have A, B, C, C, B, A. In this case, the first removal will remove the two C's. So you get A, B, B, A. Then you get A, A, right? And then finally, you get a empty string. Okay, now we have a test case. What if the input is A, B, B, G? Okay, if if this is the input, then in the first attempt you can either remove these two B or these two B. Okay, whichever pair you remove, you will be getting A, B, G. And now there is no duplicate character, right? No pair of duplicate characters. So this remains the answer. Okay. Okay, so one very commonly, or the first approach that comes to the mind is that you actually remove all these characters one by one, right? So what you will have to do is, you first remove this pair, and then you get this intermittent output, and then again in this string you check whether there is a pair which is occurring together. Then you remove this, right? This is one of the approach, but I think this should be obvious to everyone that this is going to be very unoptimized approach, right? So what should be done? Now, if you notice in this example, let's say that we have A, B, C, C, B, D. Okay, if this is the case, right? So I check A and I check B. These two are not same, right? Then I check C. Again, B and C are not same, right? So what we can do is, once we reach C and this C, correct? So now we can see that these two C's are same, correct? So now they have to be removed. But if you are removing this pair, there is a lot of chance that you will get another matching pair before and after these two C's, right? So if you get this pair, what you can do is you can maintain these pointers. So what is the character that you need to check on the left side? On the left side, you need to check the character which occurred just before this pair. On the right side, you need to check the character that occurred just after this pair, right? So you can just maintain 2 pointers and you can check this thing. And a very, very easy way to do the exact same thing is, if you use a data structure that supports these operations very optimally. Do you guys know about such a data structure which can solve this type of a case very easily? You always, so if you are moving from left to right, you are always concerned about the last seen character, right? So if first you see A, then you see B, then you see C, then you see another C. Now you know that you have to remove these two. So these two can be removed. And then comes another B. So what is the character that you need to check? The character which was entered just before C. Okay. So now you remove these two. And then comes, let's say you also have A, then comes A, right? So now you have to remove these two. So you always require the visibility of the character which was seen last, right? Or which was seen just before the character that you have removed. So stack is one such data structure that provides us this functionality, and it can be very easy to use. So what you can do is you can maintain a stack, right? And now whenever you get a character, you insert it in this stack. So you get let's say A, you insert it in the stack. Then you insert it in the stack if the stack is empty, right? Now if you get a new character, you first check it with the previously seen character. If these two are same, then you remove both of them. If these two are not same, then you enter this inside the character. So you will be pushing it. Okay. Now comes C. Again, you check whether this new character is same as the previously seen character. No. So you can again push C as well. Okay. Then comes another C. Now you can see that this C is same as the last pushed character. So you can pop this out and ignore this new C as well. So these two are removed. Now you get a B, right? So as we have seen, the concerned character is this B, which was last pushed in this stack before we pushed C, right? So now you check this B with the top of stack. You again see that these two are same. So you can remove this B as well. Then you get D. So now you can see that D is not same as the top of the stack. So you can insert it. Once the complete string is visited, whatever is remaining inside the inside this stack is going to be the answer. What if it was A, B, C, C, D, B after removing C while checking previous character and next? Okay, let's take the example proposed by Akash. Akash is asking what happens if we have A, B, C, C, D, B. First of all, what should be the answer in this case? The answer should be A remains as it is, B, D, B. This should be the answer, right? These two B will not be removed because they are not together, correct? So if you take a stack, first you enter A, then you get B, B is not same as A, so you enter, then you get C, C is also not same as B, so you push, then you get another C. Now these two C are same, so you pop this C. Then you get D, so you push D, then you get another B, you push B. Whatever is remaining is same as the answer. So it is going to work. Okay. Can we do through recursion? Yes, Ankit, you can do, but that is going to be unoptimal because after you remove one pair, you will again have to iterate over the complete string to check whether there are such pairs or not, right? How can we do it using maps? Okay, so guys, again, all the questions of strings cannot be solved using maps. There is a fixed set of pattern that you can use to where you can use map. For example, any problem where you see that frequency is being talked about, or you are being asked about what is the first occurrence or the last occurrence, right? All those types of problems can be solved using maps, but not all the problems can be solved using maps. So this cannot be solved using a map. A stack will be a better data structure to solve this problem. So let us solve one more problem before we end the class. So now this is a very, very interesting problem. The question says that you are given a string and you have to check if you can form this string, or you can construct this given string just by repeating a substring of this string. Okay, by repeating any substring of this string. For example, if the given string is ABC, ABC, ABC. Okay. Now, if this is the string, so first try to understand the problem. The problem says that you are given a string. You have to check that whether you can construct this given string just by repeating any substring of this string any number of times. For example, in this case, ABC is a repeating substring, right? So what you can do is you can just pick ABC and you can repeat ABC 3 times and then you get this complete string. Okay. Another example could be that you have AB, 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 right? So in this case, you can just repeat AB 5 times and then you get this correct, this original string, right? Or you can also have something like, let's say B, 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 B. So in this case, you can just repeat this substring of size 1 again 5 times and then you get the original string. Okay. Is the problem clear to everyone? So for this case, you return true. For this case, again, you return true. For this case also, you return true. And let's say if you have something like this. Here, there is no substring by which, by repeating which we can form this string, right? So for this, you will be returning false. Okay, Prakash has an observation that frequency of every character should be multiple of k. That is absolutely correct. But is that sufficient? Is that a condition that is sufficient to solve this problem? Sai Kiran is also saying, okay, let me take another example. What about A, B, B, B? What about this case? Do you return true here or false here? What is the substring by repeating which you get this string? So frequency of all the characters is same. A is appearing 3 times, B is appearing 3 times. Is there any substring by repeating which I can get this original string? No, right? So this is not going to work. Reverse the string from half of the string, then make a new string. If it is palindrome, okay, that is a very interesting approach, Rajiv. Let us try that out if it's going to work or not. Okay, so I can have something like, let's say, ABC, ABC, ABC. So you are saying that we should reverse this string from half, right? So first of all, from where should I reverse? There are 1, 2, 3, total 9 characters are there. So either I can reverse from here or maybe I can reverse from here as well, right? So let us reverse the last. If I reverse this part, what is the answer that I'm getting? A, B, C, A. B remains as it is. I get C, B, A, C. This is not a palindrome. If I reverse this complete part, then I get A, B, C, A, and then C, B, A, C, B. Again, this is also not a palindrome, right? Can we do it using 2 pointers? I don't know, Akshat. If you are able to do it, you can just propose your approach. Sliding window, Dikshit Garg. Sliding window, how are you going to use a sliding window? You don't know what is the size of the substring. The substring can be of size 3. This substring can be of size 1. This substring can be of size 2. This substring can be of size of any size, right? Check if repeating pattern as in wrapping card. Okay, so Tuhin, you will be checking for substrings of each and every sizes, right? LPS using KMP algorithm, yes. Ajay, that is J, that is going to work. But what is the logic behind using that? Find minimum substring and then check. So minimum substring is going to be of length 1. So how are you going to use this? And guys, there can be repetition inside the substring as well. I can have A, B, B, A, and then again A, B, B, A, B, B, A. In this case, I have a substring of length 4, which is A, B, B, A, which is repeating. There is no condition that the repeating substring should have unique characters. You can have repetition inside the substring as well. The difference between two occurrence of character must be equal. Again, Prakash, can you see this? This is violating your observation, right? Check for all the substrings which are having length, that is a factor of original string length. So again, Arun Kumar, you are going to check for each and every possible substring, right? Any substring that can be a contender, you will be checking for that, right? Can we use stack? Komal, you can definitely use anything that you want, but the problem has to be solved, right? So you are free to use any data structure. Find the distinct character in the string using map. Then use sliding window of size equal to number of distinct character. Okay. So in that case, Dipanshu, if I talk about this example, you will be using a sliding window of size 2 because there are exactly 2 distinct characters, right? But if you use a sliding window of size 2, you will get false. Whereas the answer should be true because this string of size 4 is repeating. Identify repeating string and push. Azim, that is the question. How to identify the repeating string? You are starting your algorithm from the question itself. Is this problem NP hard? No. This problem has a linear solution. Okay, guys. Let us discuss the solution. So if the string is formed by repeating the substrings, what if I join the end to the start? I have AB, AB, AB. Okay. What if I create a circular list? So AB, AB, AB. Right. So if a string of size 2 is repeating, this is my original string AB, AB, AB. If a size 2 is repeating, then from index 2, I will again have the exact same string, right? From here again, AB, AB, AB. I have another string which is exactly the same. From index 4 again, I have exactly the same string of the same length, right? If you just join the end to the start and you create a circular string, and if there is a pattern which is repeating, currently we don't know whether the pattern is repeating or not. But if there is a pattern which is repeating, then you will find the same string again and again in that circular string. We can take another example. Let's say that we have A, B, C, A, B, C, A, B, C. Okay. Now here you can again observe that this is your original string from A to C, right? And again you get same string ABC, 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 right? Starting from index 3. And then you can get another same string starting from this index, ending here, right? So you will be getting multiple copies of the same string inside that circle if you just join the end and start. So you can also assume this thing that let us say that you have a chain, right? If you have a chain, what is a chain? Chain is nothing but this is a sequence of similar type of things, right? You have a ring of gold and you attach another ring of gold to it and you keep attaching, you get a chain, correct? Now if you join these two, correct, then which is the start, which is the end, you don't know, right? You can actually say that this part is my start or this part is my start. All of them are going to give you a chain of the exact same length. Similarly, here you can assume this whole string as a chain. If you join these two, now which is the start, you don't know. From any start, you can get the exact same string of the same length, correct? Now, actually adding the end to the start is going to be difficult and that is going to be hard. What we can do is, we can add the same string. If we add the same string at the end of it. So let us say that I have AB, 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 right? Now if I add the exact same string, append the exact same string after this. So I have made an observation that if there exists such a case that a substring is repeating and then forming the complete string, then in the circular string, I will be getting multiple copies of the same string, right? I'm not able to create a circular string. Hence, I have added this same string. I have appended this string to itself. Okay. Now if in this complete string, if I am able to get a copy of the original string, can I say that a pattern is repeating? If I am able to find the occurrence of AB, AB, AB inside this string, can I say that a pattern is repeating? Okay, so I have created this string just by doubling the original string. So this will definitely be searched here and here, right? So we should make sure that we are not searching the original strings. So what we will do is we will try to search in this box. Okay. Now, if in this box, if I am able to identify an occurrence of the original string, can I say that a pattern is going to repeat? Yes, no. Let's take a generalized example. Let us not take specific example. Let's say that I have a string A1, A2, A3, A4, A5, A6. Okay. If this is the string, what I am proposing is, let us append itself to itself. So I will be having A1, A2, A3, A4, A5, A6. And now try to find the occurrence of the original string. The original string is A1, A2, A3, A4, A5, A6. If I directly try to search it, I will definitely find it here, right? Because this is the exact same string. So I will have to make sure that I'm not trying to search in the original string. So I will search in this box. Now, if we are searching in this box and if we get an occurrence, let us assume that I get an occurrence here. What does it mean? If these two are similar, right? In this case, you can see that this is the actual case, right? If you are searching for an occurrence of this string, you get it here. This means that if these two are equal, this means that A3 is equal to A1 and A4 is equal to A2 and A5 is equal to A3 and A6 is equal to A4, right? Because if these two strings are similar, then character-wise character, they are going to be exactly the same, right? So A1 is going to be equal to A5 and A2 is equal to A6. I have written this string here and this string here. Correct? Now I am able to see that A3 is equal to A1, A4 is equal to A2, and A1 is equal to A5, A2 is equal to A6. What does this mean? Let us also join these two. If these two equations are correct, then A3, A4 is going to be equal to A1, A2. Similarly, A5, A6 is going to be equal to A3, A4. Similarly, A1, A2 is going to be equal to A5, A6. Now you can see that these two are equal and these two are equal and these two are also equal. This means that each and every term is same. Now does this make sense? What have we just proved? We have proved that A1, A2 is equal to A3, A4, which is equal to A5, A6, which means that this is a substring which is repeating. Right? Let's take an example of a size 3 substring, right? So if we have ABC, 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 and okay, let's take a smaller string. Now, if let's say this is the string, first we just append it to itself. So we get ABC, ABC. Now we'll be finding the occurrence of the original string in this new string. And just to make sure that we are not searching in the first occurrence of this string, we are removing the first character and the last character. Okay. Now, if we search this string, where are we going to find it? This string can be found here. ABC, ABC. Correct? Let us write a generalized version also. So this is nothing but A1, A2, A3, A4, A5, A6. And we have appended A1, A2, A3, A1, A2, A3, A4, A5, A6. And now we are searching for A1, A2, A3, A4, A5, A6. We are searching this in this part. Okay. And as per this case, we are finding it after the third character, right? So we are going to find it here. What does this mean? This means that A4 is equal to A1, then A5 is equal to A2, then A6 is equal to A3, then A1 is equal to A4, A2 is equal to A5, and A3 is equal to A6. Okay. Again, if you just combine these two equations, what do you get? You get that A4, A5, A6 is same as A1, A2, A3. Right? This is also showing the same thing, which means that this is a substring which is repeating. Okay. Take example of ABC, BAC. Okay. ABC, BAC. Okay. This is the string which is given. We just append the same string. We append ABC, BAC. Now we remove the first character. We remove the last character. And we try to find the occurrence of ABC, BAC in this. Are we able to find an occurrence here? I can search that A is here, but then B is not there. Then A, B, C is here, B, A. So this string is not being able to find. So I am not able to find the occurrence of this string inside this this given string, right? Which means that if you join this string, if you create a circular string, you are not going to find another occurrence of the same string, which means that there is no such pattern which is repeating. Why to specifically remove first and last character? Okay. So why are we removing the first character? See, this S dash, this is the string S dash. This is created by concatenating the string S and S. This means that you have this string S, you have this string S, and by concatenating them, you have created S dash. Now you are searching for an occurrence of S, correct? If you don't remove any character, don't you think that you will directly find a match here? The first n characters are going to be exactly the same as this string because these two are exactly the same. To make sure that you are not matching it with the original copy here, we are just removing one character. Now similarly, since this is also the exact same string, We don't want S to be matched here with this second copy. So that is why we are removing this character as well. Now what we are proposing is, if you find another occurrence of S inside this part, then that means that this string, if you join the strings end and start, then you will be able to find the occurrence there, which means that there is a pattern which is repeating. Okay. Bhavya Sai, is it clear why we are removing the last and the first character? XXKS creations XX, is it clear now? Santosh, you think about that yourself. If you remove any random character, first of all, what is the purpose of removing the character? Okay. Second thing is, if you remove any random character, does our initial observation holds true? What was the observation? The observation was that if these parts are repeating, then you will be able to find another occurrence of the string inside this circular string. If you remove a random character, right, you break the link. Now these two links are not exactly the same. Right? So first try to understand what is the physical significance of removing the characters. Then you yourself think, just think that will removing a random character make sense here. Okay. You always want, what are we trying to emulate here? Right? We want to have a circular string. Right? If you can create a circular string, then we will go with that. Else, just to make sure that we are having a circular string, we are just adding the same string after it. Now this is also representation of the same string in a circular way. Okay. What about just B? Okay, Swagat has another question. What about just B? If let's say the string is B, 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 B. Okay, now what is the first step? Just add the exact same string. Then you can check in this string, are you able to find the original string? Are you able to find? Yes, this string is found here only, right? So you can say that A2 is equal to A1 and A3 is equal to A2 and A4 is equal to A3 and so on, right? So this means that you have got a repeating substring which is of length 1. Okay. Given string is B. Okay. So you are saying that given string is only B, correct? So now for this you can directly check. This is something that you can do on your own, right? You can directly check that the length of the string should at least be 2. Then only a substring will repeat, right? So I will not discuss this. You can add this to your code yourself. Okay.
Hello everyone, in this video we will study about arrays and its fundamentals. Arrays is basically a simple data structure that can also be used to build complex or composite data structures like stacks and queues. In this video we will discuss about arrays and we will see what all different operations can be performed using arrays and how arrays are stored in computer's memory. So let's start with the definition of arrays. Arrays is a collection or systematic arrangement of objects of same data types. Data types can be integer, character, double, etc. Now let's say if we want to declare an integer array, then let's see how we will do that. We will first write the data type, then the variable name, and then the size of the array. So this is the data type, which can be character, float, double, etc. This is the variable name, and this is the size of the array. Now let's see where the concept of array is useful in computer programming. So let's take a case where we have to store marks of 10 students in the class. And we have to find the average marks of all the students in the class. So if we use the integer variables, we can have 10 different integer variables, m1, m2, m3, m4 and so on up till m10, where each variable corresponds to the marks of the student in the class. And in order to find the average, first we need to find the sum of marks. which can be calculated using m1 plus m2 plus m3 plus m4 and so on up till m10. Then we can easily find the average using the formula sum divided the size, that is 10 in our case because the class has 10 students. Now let's say instead of 10 students, if we have 100 students in the class, then you can easily see that it will be very difficult to have 100 different variables. So instead of that, we can easily form an array of data type integer and size 100. We know the indexing of the array starts from 0. So M0 will represent the marks of first student in the class. M1 will represent the marks of second student in the class. M2 will represent the marks of third student in the class up till M99, which will represent the marks of 100th student in the class. Also, you can see that to find the sum using M0 plus M1 plus M2 up till M99 will also not be a good idea. So instead of that, we can easily run a for loop and let's see. So first we will have some array which will be initialized to 0. Then we can run a for loop which is starting from 0 and going till 99. And we can easily update sum as sum plus marks of ith student. And in order to find the average, we can again use the same formula, which is sum divided by total number of students in the class, which is 100. You can clearly see that it will work even if the class has 1000 students or even more than that. So this is a clear example how arrays are very useful. We can also have arrays of different data types. So in this case, we are declaring an array of integer data type, but we can also have arrays of character, float, and so on of different data types. And also this is an example of one-dimensional array, but we can have arrays of 2 dimension, 3 dimension, and so on. Now let us see how arrays are stored in computer's memory. So computer memory is divided into segments or partition, and computer memory can be considered as a very large array of bytes. So each segment is representing 1 byte of memory. And in computer architecture, each byte of memory has an address. So we can assume the bottommost address is 0. Then as we go up, we have address 1, address 2, and so on. So let's take address of this byte as 100, then this as 101, then this as 102, and so on. In C and C++, we also have pointer variables that can store these address. Now let us take our array again. So we have an array of data type integer, and let's take the size 5. We know the size of integer is 4 bytes and the total number of elements in our array is 5 and every element is having 4 bytes. So total size of the array becomes 20 bytes. Now when the program executes, the computer will allocate 20 bytes to this array. So you can assume that this 4 bytes will be given to A of 0 and computer will give continuous segments. So basically array of 1 will definitely have these 4 bytes, array of 2 will have above this, and so on. Now since memory allocation is continuous, so access and modification of the array element becomes very easy, and the access or modification of the array element takes order of 1 time. That is order of 1 time complexity. Now let us see how. So basically arrays A is also known as the pointer to the first element of the array. And A also represents the base address. So let us see using a C program how we can see the value of address and the value stored at that particular address. So let us go to a C program and let's declare the integer array of size 5. Now if you will execute this statement, printf %d is used for integers, \n is used for next line, and you will try to print a. This will print the base address or the address of first element of the array. And also if you will try to print the value at this address, which will also be an integer, in C we can print the values using x star. So star a will print the value of first element of the array. Now we see that we have only declared the array. We have not initialized the array. So at this point of time, this will print a garbage value or any random value. So if we want to test it properly, let's also initialize the array. So array of 0, let's make it equal to 2. Array of 1, let's make it equal to 4. Array of 2, let's make it equal to 5. Array of 3, let's make it equal to 8. And array of 1, let's make it equal to 1. Now if you will print this again, the base address will be printed, but the value will not be any random value. Instead, this will print 2, which is the value of the first element of the array or the index 0. Now, if you will try to execute a statement like this, that is the address of the next element, that is a plus 1, this will give you the address of the next element, that is second element. Now, let's say if the value of base address is 100, this will return the value 104. Why? Because this is a pointer to the first element of the array, that is base address, and this is known as an offset. Now offset increase the address of the base address by the size of the data type. In our case, we are using an integer variable. Integer has size 4 bytes. So this will increase the address by 4 bytes. So if the base was 100, in this case 104 will be printed. Now as we mentioned, the SS is in order of 1. So let's say if we have to print the second value or the value of second element, we can easily run this, which will be an integer because we are having an integer array. An * sign we know is used to print the value of particular address. So this statement will print the value of the second element, which we can clearly see is 4 in our case. Now SS is order of 1 because, as we have seen, when we want to try or we want to find any element in the array, the address is calculated using base address plus the offset. So let's take an example. If we have to find the value of the third element of the array, we can either write it like this, that is value basically of the fourth element, which is the third index, and it can also be seen like this, that is base address plus the offset and the value at that offset. Now please note that the pointer arithmetics only applies in C and C++ because Java do not support pointer variables, but the internal working will be similar. So this was the basics of arrays and how they are stored in memory. In coming videos, we will study more about arrays. So I hope this video was helpful, and thank you everyone.
So my name is Kshitij and I will be discussing about arrays in today's class. Okay. So in today's class, we are going to discuss some challenging problems on arrays, which can be solved just by the knowledge of arrays. In tomorrow's class, we'll be discussing some more challenging problems on 2D arrays, and then in the upcoming classes, we'll be discussing about sorting. Okay. So in the next 4 or 5 classes, we'll be discussing about arrays and sorting algorithms. Okay. So before we start the class, I just want your opinion on have you guys ever worked with arrays? Have you guys ever used arrays? Are you guys familiar with what is an array? Arrays are nothing but collection of same type of data, right? You can have an array of integers, you can have an array of strings, you can have an array of floating point data structure, or you can even have an array of objects, right? So array is nothing but a collection of data, and arrays, all the values in the arrays are stored in continuous memory locations, right? So if you have an array A of size 5, and if this is your memory, all these array elements are going to be stored in continuous memory chunks, right? So they are always in a sequence. Correct. Homogeneous collection of data. Absolutely correct. Okay. Now, in today's class, we are going to see some of the problems which do not require any algorithm, which do not require knowledge of any other data structure other than arrays. Okay. And these problems have been asked in Google, they have been asked in Facebook, they have been asked in Amazon. So if you are just familiar with arrays and if you have a basic logic building or problem solving skills, you can attempt these problems. Okay. Right. So regarding the language, so most of you are asking in which language are we going to discuss the problems, right? So let's keep the session language agnostic. Okay, we'll be discussing the logic, we will be discussing the pseudocode, but all the logics that we are going to discuss, they will be language agnostic. So whether you are coding with C, C++, Java, Python, Ruby, doesn't matter. You can apply those logics, you can apply the same solution in any language. Okay, so keep things language agnostic and let's focus on the problem solving techniques. Okay, one more thing guys, that with the class you will also be getting the problems that we are going to discuss. You will get the exact same problems, you will also get some variations of these problems. Okay, so that you can test your knowledge there, right? So I strongly recommend all of you to attempt those problems, because if you are just listening in the class and you feel that you have understood everything, you might understand things, but after a while you will forget. So it's always better to reinforce your knowledge by practicing those problems. Okay, so I will strongly recommend you guys to solve all the problems which are provided in the description link. Okay, cool. So let us start this session with a very, very interesting problem. And this problem was asked in Amazon, this has been asked in Facebook, this has been asked in Google. Okay, the problem says that you are given an array, and in this array you are having heights of some buildings. Okay, so you can consider that these are 2D buildings, 2-dimensional buildings with a width of size 1, and the height is given to you in an array. Okay, so let's say that this is the array in which you have all the heights of the buildings. Okay, now you can see this picture. So these are the buildings, right? And these black bars are the buildings, and it's raining heavily in this city. So you have got some clouds and it's actually raining heavily, and because of the rain there is some water which is being trapped between the buildings. Okay, so these are the clouds, not so good looking clouds, but yes, there are clouds, and you can see some water being trapped in between the buildings. So given the heights of the buildings, you have to identify what is the total amount of water which is being trapped in between these buildings. Okay, is the problem making sense? तो आप लोगों को एरे में बिल्डिंग्स या बार्स की हाइट दिए हुए हैं, एंड वहां पे शहर में बहुत तेज बारिश हो रही है, तो चूंकि ये 2 डायमेंशनल वर्ल्ड है, यहाँ पर कुछ वाटर ट्रैप हो रहा है इन बिल्डिंग्स के बीच में. Okay, आपको बताना है कि टोटल कितना अमाउंट है वाटर का जो कि ट्रैप हो रहा है. ओके, राइट. दिस इज अ वेरी फेमस प्रॉब्लम. इट इज कॉल्ड ट्रैपिंग रेन वाटर. This is a problem which is present in each and every platform. This is in LeetCode, this is in InterviewBit, this is in Geeks for Geeks, this is in HackerRank. This is present in each and every platform because this is very frequently asked problem, right? So what is the answer for this case? Here we can see that 6 units of water is being trapped, right? 1 unit here, then you have 1 unit here, 1 unit here. So let's actually draw the squares, right? This is 1 unit of water. Then you have 1 unit of water here. Then you have 1 unit of water here, 1 unit here, 1 unit here, and 1 unit here, right? So you have got 6 units of water being trapped between these buildings here, okay? Now the question is that given the array, you have to identify, you have to calculate the total amount, okay? How to approach this problem? Okay, so there is focus on what is contributing to the total amount. How do we calculate the total amount? So how have we counted the total amount of water in this case? To count the total amount of water, what have we done? We have just counted what is the amount of water trapped above each and every bar, right? So if I count what is the total amount of water trapped above each and every bar, and if I just add that, that would be the answer. For example, here this bar length is 0, so this bar is having 0 amount of water trapped. Here the bar length is 1, but even then the amount of water trapped above it is 0. Here the amount of water trapped above this bar of length 0 is 1. Right? Similarly, here we have 0 amount of water. Above this bar we have 1 unit of water, right? Similarly, above this bar we have 2 units of water. Here we have 1, then again 0, 0, then 1, 0, and 0. So if we just add all of these, we'll get the answer. If we just add the amount of water or the size of the water column trapped above each and every building, we get the answer. Now the question is how to get the amount of water trapped above each and every bar, right? So we have reduced the problem from finding the total amount of water to count what is the amount of water trapped above each and every bar. But how to do that? Okay, again, let's make some more observations here. Okay, so we have seen that the amount trapped above this bar is 0. Okay, why is this amount 0? Why is it not non-zero? Why is this amount? Why is this bar not able to trap any amount of water above it? Simple reason is that there is nothing on the left side to hold the water, right? There is something on the right side, but if the water falls here, there is nothing on the left to hold it, right? If there had been a bar on the left side, then you would be getting some water here, but there is nothing on the left side. So you can just consider this as a vessel which is of this L shape, right? You can consider this scenario as a L-shaped vessel. If you fill any liquid inside a L-shaped vessel, it will just flow from here, right? You cannot trap the liquid in a vessel which does not have the boundary, right? So that's why here we have 0 amount of water. Now, what about this bar? This also has 0 amount of water. What is the reason for that? This is not 1. This has to be 0. What is the reason for this? Again, the same reason. This bar also does not have anything on the left side to hold the water, right? That's why this is also not trapping anything. When we come to this bar has got a size 0, but it is able to trap a water column of height 1. Simple reason being, it has got something on the left and something on the right as well. So now this is forming a complete vessel, right? So it can hold water, a water column of size 1. Now we come to this bar again. This has got a bar which is on the left side, right? If I'm talking about this bar here, this has got a bar on the left side. Even after that, this bar is not able to hold any water. Why? Because the bar which we have on the left side has got a smaller height, right? If you have to hold some water above this bar, you need something on the left and something on the right of a higher height, right? So you can assume that this is the surface of your vessel. Now, this bar here is below the surface, right? So you need something which is higher the surface. Then only you can trap some water inside this, correct? So that is why this is also not able to trap anything. Now, when you come here, this has got something on the left and something on the right as well, correct? So one thing which is very clear from this observation is that to trap the water, you definitely need something on the left side, something on the right side of a higher height than the current bar, right? This bar is not able to trap because it doesn't have anything on the left. This bar is able to trap because it has a support on the left side as well as on the right side. So it has got both the boundaries, correct? Cool. Now the question is, how do we, so we have determined that some of the bars will not be able to hold, but the bars which are holding the water, how much water is going to be there, okay? Now to do that, to actually analyze that, let's consider a very simple example first, okay? So let's say that the heights of the bars are 2, 1 and 3. So we have got a bar of size 2, then we have got a bar of size 1, and then we have got a bar of size 3. And we are talking about this middle bar. We have to identify what is the amount of water being trapped above this middle bar, okay? This has got height 2, this has got height 1, this has got height. Can you guys quickly respond what is the amount of water which will be trapped above this bar? The size of the water column here. Is it going to be 1? Is it going to be 2? Is it going to be 3? It's going to be 1, right? Why 1? Because the height on the left side is this height is of size 2, right? And we have this bar till height 1. So the only limited space that we have for the water is this column. Anything above it will flow from here, correct? Okay. Let's change the example. Let's add some more bars here. Okay. So initially we have this configuration where we have bar of size 2, 1 and 3. Now I'm going to add one more bar on the left side. And this bar is also of length 3. Now how much water will be trapped above this bar? Is it still going to be 1? Or now will we have some more water here? Yes, it's going to be 2 this time. Why? Because now we have got a higher support on the left side, right? So if it is continuously raining, all this area will be filled with water, right? And now we can see that this column, the height of this column has now become 2, right? The height of the water column trapped above the above this bar has now become 2. Height of the water column above this bar has now become 2. Okay. Why has it become 2? In this case, it was 1. Now it has become 2. What is the reason? What is the reason? The reason is the addition of this bar. Right. Let's add some more bars. Okay. Let us add some more bars to this configuration. So I will be adding a bar on the left side. Let's raise a bar of size 4. Will the height of the water column stored above this will increase? If I have just added a bar on the right side of length 4, will the height of the water column above this bar, is it going to increase? No, right? Because on the left side, it is still 3. On the left side, the maximum that we can have is still 3. Anything above it is going to flow from here. If we also add another bar of size 4 on the left side as well, now will it increase? Yes, now it's going to increase because from both the sides we have got a height of size 4, right? So is this complete observation making sense to you guys? The height of the water column stored above any height is nothing but the minimum of the maximum height that you can get on the left side and the maximum height that you can get on the right side, correct? The height of the water column stored above this is minimum of maximum height available on right and maximum height available on the left. So if I have to identify what is the height of this column, right? Height of water column above bar I, this is equal to, this is nothing but the minimum of maximum bar on left side, maximum bar on right side, minus the height of bar I. So if I'm talking about, if this is my ith bar, the water column trapped above this bar is how much? This is minimum of maximum of left, maximum of right, minus the height of this current bar. If I have to calculate the total amount of water, this is just going to be the sum of all such values. Correct? So the answer that we are going to calculate, sum of this value for each and every height, right? Sum of minimum of left max, right max, minus height of bar. So I will be calculating the minimum of left max, minimum and right max for each and every bar, subtract the height of that bar and keep adding it. So whatever we get at the end is going to be the answer. Correct? Let's quickly do this thing on the given example. Right? What is the minimum? What is the minimum on the left side for this? Minimum on the left side for the first bar is 0. There is nothing on the left. Sorry, maximum on the left side, right? Maximum on the right side is this bar of length 3. But since we are taking the minimum of left max and right max, minimum becomes 0. 0 minus the height of the bar is 0, right? So this is not going to hold anything. What about the first one? Again, left max is minimum. Left max is 0. So we won't be getting anything, right? For this bar, for this water column, the left max is 1, right? The right max is 3. So minimum of left and right is 1 minus the height of this bar, which is 0. So this is going to hold 1 unit of water, right? So if we do the same thing for each and every bar, we are going to get the answer. Let's also see for this column. So here, what is the left max? Left max has got a height 2. Right max has got a height 3. Minimum of 2 and 3 is 2. Right? So this bar is going to hold 2 minus the height of this, which is 0, this much amount of water. So we just have to do this thing for each and every bar, and we add whatever amount is trapped over that bar, and we get the answer. Okay. Okay, let's do this in this example. Let me just clean it up a bit. Let's try to calculate what is the total amount of water that will be trapped in this scenario. Okay, if this is the landscape of the buildings that we have, what will be the total amount of water trapped here? Okay, so we are saying that the total amount of water trapped is the sum of water trapped above each and every building. What if negative? Heights are not going to be negative, right? Negative height means that you are digging a hole and then you are, so it's basically kind of a plinth. So you can assume that such buildings with negative heights are not possible, okay? Okay, let's try to run our approach on this thing, okay, on this scenario. So for this building, what is the maximum height on left side? Maximum height on left is 0. Maximum height on right is 4. For the first building, the answer is going to be 0, right? For the second building, maximum height on right is 4. Maximum height on left is 4. Maximum height on right is also 4, right? So we'll be getting minimum of these two minus whatever is the height of the building, which is 3. So this is going to contribute 1 unit of water, okay? Then in the next building, so the 1 unit of water comes here. In the next building, we will be checking minimum of what is the left max. Left max is still 4. What is the right max? Right max is still 4. Building size is 2. So we get 2 units of water above this, okay? Similarly, for the next buildings, again, left max, right max are 4 and 4. Building height is 1. So we get 3 units of water above this. Okay. Similarly, we'll be doing for this as well and this as well. And Once we add all these values, we'll be getting the answer. Okay, cool. So now once this is clear to everyone, can you guys tell me what is going to be the time complexity of this approach? So for every bar, we are calculating a maximum on the left side, we are calculating the maximum on the right side, and then we are applying this observation and getting the height. What should be the time complexity if we go by this approach? Okay, let me just reiterate over this example again. For if I'm calculating for this bar, I will have to calculate what is the left maximum. To calculate the left maximum, I will be iterating over all the possible bars on the left side. To calculate the right maximum, I will be iterating over all possible bars on the right side. How much time is this operation going to take? This is going to take order n. How much time is this operation going to take? This is also going to take order n, right? So to calculate the water column above each and every bar, we are doing an order n operation because these two are going to get added, right? And we are going to do this operation for each and every bar. There are n bars in total. If there are n bars and for every bar, our calculation requires order n time complexity. What is going to be the total time complexity? Right, so there are n bars. For every bar, we are going to do order n operations. So the total time complexity is going to be order n squared. Okay, can we optimize this order n time complexity? In the last class, you must have learned that order n is not a very good time complexity, right? Yes, Vijender, you are absolutely correct. Right, guys. So to optimize the time complexity, again, let's make a very simple observation, right? So till now, we have deduced that for every bar, we have to calculate the left max and the right max. Okay. Let's talk about the last bar. Okay. If I'm talking about the last bar, then we are calculating the left max for the last bar. How actually we calculate the maximum for this? The order and operation of the maximum, of finding the maximum. How do we run it? So we will be declaring a max, right? And we'll keep updating it after visiting each and every bar. So we'll initialize a maximum value. We can initialize it with a very, with maybe minus infinity or maybe a not possible or zero. Maybe we can also initialize it with the length of the first bar. Okay. So we say that currently the maximum is this, and we'll keep updating the maximum as soon as we visit all the bars in this order n loop. Right. So if let's actually take a complex example. So if the bars are of size 2, 3, 1, 4, 5, 2, 1, 7, okay, 2, 9. If these are the lengths of the bars, if I have to calculate the maximum from left for this last bar, right, I will be starting from here. Okay. Let's initialize the maximum with 0. Okay, so we are saying that whatever is the maximum between the current maximum and the current bar is going to become the maximum, right? So maximum is initialized by 0. When we reach here, we say that 2 is the maximum. Then when we reach here at 3, we compare this value with the current maximum, right? This is how we calculate the maximum of an array, correct? So we calculate current value of the array with the current maximum. So 3 becomes the maximum. Then we compare this 1 with the current max. Let's call it the current max. Okay. Again, 3 remains the maximum. So we'll fill 3 here. So this means that till this point, 3 has got the maximum height, right? Now similarly, for the next step, we'll be comparing 4 with 3. Okay, so this gives us 4 as the maximum, then it gives 5, and then we'll be having 5, 5 till this point. Then we get 7, and then 7 continues to here. So the maximum for on the left side for this bar is 7. Okay. Now in this process, if you have observed, what have we done? We have not only computed the max for the last bar, but we have also computed the left max for each and every bar. So if you just store all these values in an array, instead of just keeping a variable of the current max, if you just have an array and store all these values inside the array, these values are corresponding to the maximum height on the left side for each and every index. Is this making sense? Till this point, 5 is the maximum. Till this point, again 5 is the maximum. Right? Till this point, 7 is the maximum. So while you are calculating the maximum value for the last bar, you have not only calculated the maximum on left for the last, but you have also calculated the maximum for each and every index. So in a single iteration, we have the values of left max for each and every value. Okay, let me just repeat. Let's clear each and everything here. Let's do it once again. Okay, so when we have to calculate the maximum on the left for the last bar, first of all, is everyone clear that we will be calculating the left max for each and every bar and right max for each and every bar? Yes. Now, let's talk about this guy. Let's talk about this bar. If you have to calculate the left max, you will be iterating over this part of the array, right? You will maintain a left max for this bar, and you will keep updating that left max while visiting the array. Right? You will initialize a left max with 0. You will check whether 0 is greater or this value is greater, right? So you will keep updating this left max while iterating over the array. Similarly, you will do the same thing for the right max as well. Correct? Now let's talk about the last element. Let's not talk about the middle element. Let's talk about the last element. When we are doing it for the last element, we are actually calculating the left max for each and every index, right? Left max till now is 0, right? Or let's call it 2 here. So we have initialized the left max by 0. We compare it with 2, we get 2 here, then we get 3 here, right? Then we get 3 again here, then we get 4 here, 5 here, 5 continues, till we get a longer height, which is 7, right? And again we get 7 here. What if 9 is not present? Then also you do the same thing. If 9 is not present, you have 1 bar less in your structure. Then you will be, when you calculate the left max for the last index, doesn't matter whether it is 9 or any other number. When you are calculating the left max for the last index, you have actually calculated the left max for each and every index in this process. The only thing is that you will have to store these values. Instead of updating the current max variable, if you just store these values in the array, you get the left max for each and every index. Similarly, while calculating the right max for this index, the first index, you will be calculating the right max for each and every value. Correct? Because to calculate the right max for the first index, you will be iterating from the right side, and you will keep updating all the values one by one, right? So you start from here till now the max is 2, then you get 7, and then 7 continues to be the max till now. Okay. So is this observation making sense? The observation is that we don't need to run this order n loop for each and every index, because when you are calculating the left max for the rightmost element and when you are calculating the right max for the leftmost element, you are essentially calculating each and every value which is required in this calculation. So instead of running these two loops of order n on each and every index, what we can do is we can just run a single loop and we can store all the required data. We can do some pre-computation. Okay. We need two extra arrays. Yes, we will be needing two extra arrays. Let's call this array as the left max array, and let's call this array as the right max array. Okay. If we have stored these values, can you guys now tell me what will be the amount of water stored over any ith index, stored over any ith bar? If I talk about this bar, what will be the answer? What will be the amount of water stored over this bar? we need the maximum bar. We need the maximum bar on the left side of this. From where can we get it? The maximum bar on left side of this bar is here, right? We have already calculated it. The maximum bar on the right side of this bar is present here. If we are talking about the ith index, the left max is stored at left max I minus 1, and the right max is stored at right max I plus 1. Okay, you don't need to run 2 loops for each and every number. We can just pre-compute the left max and right max for each and every index, and using these values, now we can have a different loop and we can get these values in order 1. Okay, what if we store in the ith index itself? Will that work? That will definitely work, Anushka. You will just have to check. Like you can also store for every ith index, you can store what is the left max height at this index and right max height at this index. You will just have to calculate. You will have to this. You will have to keep check on the corner cases. Okay, if you are able to keep checks on the corner cases, then that will also work. Okay, so let's quickly see the pseudocode. Okay, so we can have a left max array. Okay, what will be the size of this array? Size of the array is going to be same as the size of the input array, because for each and every index we want this information, right? So its size should be equal to n, whatever is the size of the input array, correct? And similarly, we'll also be having a right max array, which will store the right max for each and every part. Okay. Then let us initialize these values. So we can say that left max of 0 can be initialized from the array 0. Okay, and right max of okay, let's come to the right max after we finish this, right? So we have initialized this for the 0th index. That means I'm saying that for 0th index, this is the answer. The height of the bar is the answer. Now for the remaining bars, we can just run a loop, which will start from some point, go till n, and we'll be doing it. From where should we start the loop? Should it start from 0? Should it start from any other number? Yes, the loop is going to start from index 1, because we have already filled the value on index 0. So we don't need to start from index 0. Okay. And for every index, we can say that left max of I is nothing but the maximum of the previous max, which is left max of I minus 1, and the current array value, the current height. So whatever is the maximum between the current height, right, between the current height and the previous is going to be the left max of this iteration. Okay. Similarly, for the next value of I, we'll be comparing this value and this value. Okay. So we have our left max array filled up. Now we'll also initialize the right max array. So for the right max array, how did we start? We started from the right side, right? We said that we are starting from here, and let's copy the array value, the last array value in the last index of the right max array, because for this value there is nothing on the right side. So we are starting from here. Okay. So right max of n minus 1 is going to be array of n minus 1. And now similarly we can have a loop which will also start from some number, go till 0, and this is going to run from right to left. So that's why we are doing I minus 1. So from where should we start it? This loop will start from n minus 1. We have already filled the value for n minus 1, right? So this should not start from n minus 1. N minus 1 is some value which is pre-required to compute the value at this index. So we'll be starting from the index n minus 2. Right? To calculate the value here, we need to compare this value, which is the previously calculated value, and the current height. Okay. So let's go back here. We'll be starting this from n minus 2. and right max of I is going to be the maximum of what will come here? Yes, it should be I plus 1, because now when I'm checking for this index, I'm comparing this value. If this is index I, this is I plus 1, not I minus 1. In case of left max, we were comparing with the previous index. Now we are comparing with the next index, right? So this is going to be right of I plus 1 and the current array value. Okay. So now we have got the left max and the right max array populated. Okay, now we just have to run a single loop to calculate the total amount of water trapped. So you can have a variable water initialized with 0, and now we can run a loop, and this loop should run for each and every height. So we'll start from I equals to 0 less than n. We'll be incrementing the I with 1, and we can simply say keep adding the amount of water trapped over each and every bar in this variable. So water plus equals to, or you can also write it as water equals to water plus the, how do we calculate the height of water column? Minimum of left max, right max, right, minus the array value I. Cool. What is the time complexity of this approach? Time complexity of this is, see, first in this code, first we are populating the left max array. For each and every bar, we need what is the left max. So this is going to count order n, plus this array, this loop is also going to be of order n, plus this loop is also going to cost order n, right? So the total time complexity of this approach is order. Yes, order 3n, which asymptotically is same as order n, right? Order 3n is nothing but this is same as order n, because when you calculate the time complexity, you ignore the constants, right? Edge case missed, right? So if this is just a pseudocode, okay, now you have to attempt this problem, you have to solve it on your own, and in the code which you are writing, you have to take care of all the edge cases as well. Okay, Himanshu, that is on you now, so you have to do it on your own. Okay, what is the space complexity, guys? Can you tell me what is the space complexity? We are using two arrays of size n, right? So it is going to be order n in space as well. Okay, let's do one thing. Let me just tell you the problem. Okay, this is also a very, very interesting and very frequently asked problem, which is called the majority element. The problem says that you are given an array. You have to find the majority element in that array. The majority element is the element that occurs more than n by 2 times. Okay, which means that the number of times that element is occurring in the array should be strictly greater than n by 2. For example, if this is your array, 3, 3, 4, 2, 4, 4, 3, 4, 4. Can you guys quickly tell me what is the majority element in this array? N, which is the size of the array. What is the size of the array in this case? 9, right? Now, which is the element which is coming more than 9 by 2 times? Correct. Majority element in this case is 4, because 4 is occurring 5 times. Okay. 4 is the majority element here because 4 occurs 5 times. Let's take another example. Let's say we have 3, 3, 4, 2, 4, 4, 2, 4. What is the majority element in this case? Size of the array is 8. What is the majority element which is occurring more than 4 times in this case? 4 is occurring 4 times, right? But we need something which occurs more than n by 2 times. 4 is not more than 2. So in this case, we do not have any majority element. Okay? No majority element. So you have to, if there is a majority element, you have to return that element. If there is none, you can return none. Okay? This is the problem. Is the problem clear to everyone? What would be a brute force way to solve this problem? What if two elements are majority elements in the same array? Guys, that is a very, very interesting thing that Satyam has asked. Can there be two majority elements inside a single array? Satyam, think about it. Can there be two elements which are occurring more than n by 2 times? No, right? How 4 is greater? 4 is not greater than this, but the count of 4 is 5. Right? We have to count the number of times this element is occurring. We don't have to return the element which is greater than n by 2. We have to count the number which is occurring more than n by 2 times. Okay. Cool. So what is going to be the brute force solution here? Brute force solution is going to be simply you run two loops for each and every element. You just check whether that element is a majority element or not. Select this element. In the remaining array, count the number of occurrences. If the total number of occurrences is greater than n by 2, return it. Otherwise, go to the next element. Check for this element in the remaining array. If it is occurring more than n by 2 times, return. What is going to be this time complexity of this approach? It's going to be order n square. Why? Because you are running two loops of size n. Correct? Okay, so brute force is not going to work. This is too slow. How can we optimize it? Using hash map, right? So some of you are saying that we can use hash maps. If you use a hash map, first of all, how can we solve this problem using a hash map? So this is a very, very good suggestion that use a. What is hash map? Is everyone clear with that? If you are not clear, you can skip this. If you are clear, you can think in this direction. Hash map is nothing but a key value pair, right? So you can have a key and you can have a value in the hash map. Now every array element becomes the key and the frequency becomes the value. So against 3, you keep 1. Then you again go to 3. You see that 3 has already occurred in the hash map. You increase the frequency. Okay. Then you go to 4. 4 is not occurred yet. You keep it and you put 1 here. So after you have iterated all the array, yes, it's totally like the dictionary in Python. Okay. After you have iterated all the array, you will be having all the array elements along with their frequencies. Okay. So 4 will be 5 at the end because the frequency of 4 is going to be 5. And the frequency of 3 is going to be 2 and 2 is also going to be 2. This is the value, the array element, and this is the frequency. After you have made this complete map, you can iterate over all the keys and you can figure out which of them is the majority element. This is one of the approaches. What is going to be the time complexity of this approach? If you are not aware about what is a hash map, you can totally skip it. We will be covering hash map in details in the upcoming sessions. But if you are clear about hash map, then you can just think about what is the time complexity of this approach. This is going to be order n time complexity, correct? What is the space complexity here? You are using a hash map which is going to cost you order n space, right? Order n time complexity plus order n space complexity. Okay. You have to solve this problem in a linear time with constant space. Okay, this has to be your time complexity, this has to be your space complexity. Is the requirement clear to everyone? You cannot use a hash map. If you are not clear about the hash map approach, completely skip it because this is something that you cannot use in the question. Okay, you have to solve this problem in order n time complexity, order 1 space complexity. Okay, think about it. This is going to be something which we'll discuss in the next class. Right. So in today's class, we'll first discuss the majority element question that we discussed in the last class, and then we'll solve one more problem which will be based on a 2-dimensional array. Okay. So the problem that we left unsolved in the last class was that you are given an array and you have to find the majority element of that array. The problem says that you are given an array And in this array, you have to find the majority element. Okay, the majority element is an element which is occurring more than n by 2 times, more than n by 2, where n is the size of the array. Okay, so if the array size is 9, the element has to be there at least 5 times. Okay, it is possible that there is no majority element in the array, because there might be a possibility that there is no element which is occurring more than n by 2 times, right? Correct. So the brute force way to solve this problem, as proposed by Sai, is that you run 2 loops, and for every element you check the number of count of that element in the array, right? So you will start from the first element, you will select this element, then you will check in the remaining part what is the total occurrences of this element. Okay, you can then see if the total occurrences is greater than n by 2, you can return it. Then you will check for the next element, then you will check for the next element, and so on, right? So you will have 2 loops. One will be selecting a prospect candidate, the other will be checking if that element is a majority element or not. This approach is going to cost you order n square time. Okay, we discussed a more optimized approach also, which was involving a hash map. If you use a hash map, what will be the time complexity? If you use a hash map, since in hash map you can store a key value pair, right? So a hash map is nothing but a key value pair. If you are using Python, you can think in terms of a dictionary, right? So key can be your array element, and the value can be the frequency of that array element. So you iterate over the array once, and you keep the count of frequency of all the elements in this hash map. Once everything is done, or while calculating the frequency only, you can just check if there is an element which occurs more than n by 2 times. If any element occurs more than n by 2 times, then you can return it. Okay. So this approach is going to cost you order n time, but order n space as well, because you will be using hash map. Okay. How to create hash map in C? You can use unordered map in C. Now, the question here is that we have to solve this problem in order and time complexity without using any extra space. So we have to solve this problem in constant space complexity without using any extra space. Okay. Okay, so most of you are saying that now you will apply the Moore's voting algorithm, which is absolutely correct. Okay. Okay, we have one more approach. The other approach says that you first sort the array. If you sort the array, since the majority element is going to occur more than n by 2 times, right? And once you sort the array, all the similar elements will be arranged together, right? So some similar elements will be there. Then if there is a majority element, then it will also be there. And then some different elements of similar type will be arranged together. If there is an element which is occurring more than n by 2 times, once you have sorted this whole array, either you can do a linear iteration, or maybe you can just check the middle element and check the count of that element as well, right? So if you sort the array, what will be the time complexity? If you are using the most efficient sorting algorithm, even after that, what is going to be the time complexity of sorting the array? It's going to be order n log n. Right? You can use quick sort, merge sort, or heap sort, right? And all these sorts are going to run in order n log n time complexity. If you are not sure about all these sorting algorithms, we will be covering them in the upcoming classes. So don't worry about it. If you already are familiar with the sorting algorithms, then you can sort this array, and then you can iterate over the array and count the occurrences of all the distinct elements, right? So in that case, the time complexity is n log n, which is absolutely greater than order n, right? So this is again not an optimal approach. Okay, so let's discuss the idea behind the most optimal approach for this problem. Okay, let's try to change the perspective. So first, let's consider an example. Let's take this example only. Okay, so if there is a majority element, the question says that the majority element will be occurring more than n by 2 times, right? The count of majority element is always going to be greater than half the size of the array. If there exists a majority element, can I say that the collective counts of all the other elements will always be less than n by 2? If majority element exists, if there is a majority element, can we say that the count of all other elements combined will be less than n by 2? Obviously yes, right? Because half of the array has been occupied by the majority element. If you collect all the majority elements together, starting from the 0th index, and if this is the n by 2 mark, the majority element will definitely occupy, starting from 0, it will go more than n by 2. Right? So the remaining space that is left in the array is obviously less than n by 2. Correct? Okay, now if this is the case, if everyone is convinced that the count of all the other elements combined is going to be less than n by 2, now let's try to see this whole scenario in terms of, let's say, election results. Okay, let's actually consider all these array elements as the results of an election, result of different constituencies. Okay, so these are different parties. This is a party 4, this is a party 3. Okay, and let's try to see in terms of the election results. Okay, so the party to which the majority element belongs, okay, in this case is going to have 1, 2, 3, 4, 5. 5 constituencies have been won by the majority element, right? And if we collect all the other elements together, this is going to be 1, 2, 3, 4. Okay, so we have some other element A and some other element B, right? So these are the results from different constituencies. These 5 constituencies have been won by the majority element, and all these are won by different candidates. Okay, so if you remember the 2019 general elections, there was a party BJP which was in majority. And then there was something called as Mahagathbandhan, right? So in Mahagathbandhan, there were various parties which they combined hands and they were fighting against BJP all together, right? So you can just assume that these all are the constituencies won by the Mahagathbandhan, and these all are the constituencies won by BJP. Now, if the election commission says that 2 out of all these constituencies are being disqualified, there has been some cheating in 2 of these constituencies, so we are removing the results, we are not counting the results of these 2 constituencies. So if the election commission says that one of BJP's constituency and one of the Mahagathbandhan's constituencies will not be counted in the election result, if these 2 are removed, who is going to win the election? If 2 constituencies here are removed, who is the new winner? Initial winner was BJP, right? Now who is the new winner? You can quickly count the total votes and quickly see who is winning it again, right? It's still BJP, right? So what we have done, if you look in terms of this array, you have removed one occurrence of the majority element, and with that you have also removed one occurrence of a non-majority element, right? So we have reduced the size of the array by 2, and the occurrences of the majority element has been reduced by 1. Okay, let's say 2 more constituencies were removed. So one from BJP and one from Mahagathbandhan again were removed. Who is the winner? Who is the new winner now? It's again BJP, right? You can quickly see that it is still in majority. It is still having a size more than n by 2, right? So what we have done here is we have removed one occurrence of the majority element. With that, we have also removed one occurrence of a non-majority element. Okay. Again, if you do the same thing, you can see that BJP still remains in power. If you remove 2 more constituencies, we have only one constituency left, which is of BJP. So the idea is that if with every occurrence of the non-majority element, if you remove one occurrence of the majority element, at the end, you will be left with at least one occurrence of a majority element. So the idea here is that if I am removing one occurrence of any non-majority element with one occurrence of a majority element, the majority element still remains the same. Let's try to see it from other analogy as well. Okay, one another analogy could be that there are two countries, or let's say there are 3-4 countries, and 3 countries are fighting against one country combined. So there is a country C1, there are country C2 plus C3, and let's say C4. Okay, now C1 has got majority of soldiers, right? So the soldiers that C1 has, let's denote them as S. So let's say it has got 7 soldiers. Okay, and all these other countries combined, okay, or let's say that let's represent all these soldiers by I. Okay, then we have some more countries, and we have 3 soldiers in the country C, or let's say 4 soldiers in a country C. We have 2 soldiers in a country P, and we have 1 soldier in a country B. Okay, now since initially the number of soldiers in the country C1 have outnumbered all the soldiers in all the other countries combined. Now, if one soldier here dies with one soldier of any of these countries, who is going to have majority of the soldiers? Will that change? So initially C1 is in majority, right? Now, very similar to what we saw in the election, if this soldier dies with this, if these two kill each other, still C1 has got more number of soldiers, right? Actually, here we have one less soldier. Now it is in majority. So initially it is in majority, right? Now if one soldier of C1 kills or dies with one of the soldier of all these countries combined, still C1 is in majority. The idea is, if you are removing one occurrence of the majority element with one occurrence of any other element, the majority element still remains the majority element. Can we use this idea to solve this problem optimally? Let's now bring back our example again, and let's try to do a dry run on the example. So we have all these numbers. Now, if I remove one occurrence of the majority element with one occurrence of any other element, let's see what remains the result. Okay, so if I'm removing 4 with 2, 4 is still the majority element of this remaining array, right? If I remove 3 with 4, again 4 is the majority element, right? If I remove 3 with 4, again 4 is the majority element, and finally we are only left with 4. Okay, cool. Now the question is that you don't know initially which one of these is the majority element, right? If you don't know which one out of these is the majority element, how are you going to cancel the occurrences of all the other elements with the majority element? The question is, do you need to know the majority element? If I slightly change the initial observation, so initial observation was that if we are removing one occurrence of a majority element with one occurrence of a non-majority element, the majority element remains the same. But if I change this observation to, if I remove 2 distinct elements at a time, if I remove 2 distinct elements at a time, the majority element remains the same. Will this also be correct? If instead of always selecting one of the majority element, if I'm selecting any of the 2 elements, making sure that the 2 elements are distinct, that is also going to cause the same effect, right? Because if you are not selecting one of the majority element, then this will definitely be in majority because you are not removing it, correct? So you don't need to know the majority element initially. Okay, what you need is what is the current element that you have, okay, and what is the count of other elements. So if we are here, if you are trying to find the majority element in this array, you don't need to sort, you don't need to get the counts of all the elements. What you can do is you can just maintain a variable and you can maintain the count. So initially when you are at 3, you can say that 3 is your majority element, count is 1. When you get another occurrence of the same element, you can just increase the count. Now you get a different element. When you get a different element, you can say that since this element is not same as this majority element, you can remove these two occurrences from the array. So you are not counting it and you are removing, you are changing this count to 1. So this means that you have removed one occurrence of 3 and you have removed one occurrence of 4. Then you go to 2. Again, you get an element which is not same as the current majority element. So you will cancel out both of them. So now you are removing this occurrence of 2. So you are not counting it and you are also reducing this count from here. Okay. Then you go to 4 and now you see that 4 is the new element and the current count of majority element is 0. That means if count is 0, there is no element that you have here, right? So now you can change your majority element to 4 and the count now becomes 1. Okay. Then you again go to 4 and you see that this is same as the initial element. So you will now increase the count from 1 to 2. You go to 2, you find that this is a different element. You can remove the counts. So if you remove the counts, you are not counting 2 plus you are decrementing the count of current majority element. Then again, you see that here you have 4. So you will increment the count. Again, you get 4, you increment the count. The final element that you are getting with non-zero occurrences can be your majority element. Okay. Great. If this is clear, will this always be the majority element? Will the final element which we are getting, is it always going to be the majority element? No, not necessary. This is not necessary that this element is always going to be the majority element, because there can be cases where there is no majority element in the array, right? This one. So in that case, whatever answer you finally get, you will have to actually count the occurrences of that in the initial array. So here if you get 4 with a count which is greater than 0, you will again you will run a loop over your initial array and you will count the occurrences of this prospect majority element. This can be the majority element, not sure. Okay, this is a prospect. This is the only candidate for a majority element. So if you get something here with a non-zero count, you will just check here and count the occurrences. If they are greater than n by 2, then you can say that this is the majority element. Okay, I will just repeat the counting part again. Okay, how we are counting. So is everyone clear with the idea of this algo? The idea is that whenever you get two distinct elements, you remove them. Okay, if you are getting two distinct elements, you remove the occurrences of those two distinct elements. So if I'm getting 3 and then let's say if I'm getting 4, I will try to remove both of them. Okay. So what we are doing here is we are maintaining a current majority element and we are maintaining a count. Okay. So if you get 3, you increase the count. So you have, let's consider a different example. Okay. Let's take an example given by Vijay Sai, which is 3, 3, 3, 4, 4, 2. Okay. So we will be maintaining a majority element and we will also be maintaining a count. Okay. You get 3, you say that 3 is the current majority element. I don't know what is going to be after 3, but 3 will be the majority element. Count of 3 currently is 1. Then you go to 3 again. This is same as the initial or the current majority element. So you increment the count to 2. Okay. Then you go to 3 again. You will increment the count to 3. Then you go to 4 and now you get a different number. What was the algo? What was the initial observation that we made? The observation was if you remove two distinct elements, the majority element remains the same. So if I get two distinct elements, I will cut them down. So I will not count the occurrence of 4. So I am ignoring 4 and simultaneously I am also reducing the count here. Okay. Then I get 4 again. I am again reducing the count. Then I am getting another different number. So I am reducing the count. Count becomes 0. If count becomes 0, that means there is no majority element. If let's say there was another 3, and okay, so in this case basically you are not going to get a non-zero count, but it might be possible that you can get a non-zero count even when you don't have a majority element, right? So you can have something like 1, 2, 3, 4, and then let's say 5, 5. Okay. In this case, if you run the same algo, you will get a non-zero count at the end, but there is no majority element in this array. So after you get a non-zero count, you will have to check in this whole array. You will have to count the number of occurrences of your prospect candidate. Okay. Okay. Rahul is asking, will it work for n by 3 problem? Yes. Okay. So in this case, the question was that majority element should be occurring more than n by 2 times. Now there is a variation of the same question which was asked in Google, where the problem says that your majority element is an element that occurs more than n by 3 times. Okay, now using the same concept, you have to solve this problem. Okay. Yes, Ayush, this will work. Okay. If you want, you can also try to see it mathematically. Okay, you can just take an array of size n. Let's quickly see how if it is going to work mathematically or not, right? So the initial size of the array, size initial is equal to n, right? If you are removing 2 elements, then the size will be n minus 2. Now, if there is a majority element, then what should be the minimum count of that majority element in this initial array? That has to occur more than n by 2 times, right? These many times. If you have removed 2 elements, from this array, at least one of them can be the, or at most one of them can be the majority element, because you are removing 2 distinct elements, right? So the count of new majority element in this array is going to be n minus 2 by 2 plus 1, right? Is it making sense, guys? So the initial size of your array was n. After removing 2 elements, the size becomes n minus 2. Initial count of the majority element was greater than n by 2. So the minimum count would have been n by 2 plus 1. Now the count is size by 2 plus 1, right? And if you have removed 2 elements, only one of them can be the majority element, right? So what would be the new count of this element? The new count of this element is going to be the initial count minus 1. This is going to be n by 2. Okay. And if you solve this, this is also going to be n by 2. So you can see that this is the count of majority element which should be there in this array of size n by n minus 2. And this is the count of the initial majority element. So you can say that the initial element still remains the majority element. Now you can do the exact same exercise for n by 3 also, and you can check whether the same algo is going to work or not. Okay. What is the time complexity of this whole algo? So we are running a single loop, right? We are running a single loop and we are just maintaining the current majority element and the count. Okay. So the single loop is going to count you order n time complexity. What about the space? We are using only 2 variables, right? We are not using any array. We are not using any hash map. We are using only 2 variables. So the space is going to be constant. So will you be able to write the code for this? Could you go through an example of n by 3? Example of n by 3 is there in the test that you have received yesterday, right? You can just go through that problem and examples are listed there. You just have to check using this exercise that will the same approach work or not. If you are able to do that, then you can solve that problem as well. Okay, let's solve the next problem. Now the next problem is also a very, very interesting problem. Yes, the algo that we have discussed, this is the Moore's voting algorithm. Okay, so let's discuss the next problem. In the next problem, you are given a matrix. Okay, this matrix is sorted row-wise. All the rows of the matrix are sorted and all the columns are also sorted. Okay, what is a matrix? Matrix is nothing but a 2-dimensional array. Okay, so all the rows are sorted in ascending order and all the columns are also sorted in ascending order. So here we have a matrix which is sorted all. So you can just quickly observe all the rows are sorted in ascending order and all the columns are also sorted in ascending order. Okay. You are given a target and you have to search the target in this matrix. Okay. So for example, if your target is 37, you have to identify whether the target is present in this matrix. If it is present, then what are the coordinates? Okay. So if the target is 37, 37 is present and it is present here, right? So you will be returning the coordinates of 37 in this matrix. Okay. Is the problem clear? Okay. For those for whom the problem is not clear, I will quickly repeat it again. You are given a matrix where each row is sorted in ascending order and each column is also sorted in ascending order. Okay. Then you are given a target and you have to find and return the coordinates of the target in this matrix. The dimensions of matrix is n cross m. Okay, what is the brute force here? Can everyone solve this problem using a brute force algorithm? We simply have to start from here. Okay, then traverse all the rows, each and every element, check if that is equal to the given target or not. Right? If you do this, what is going to be the time complexity? If you are traversing each and every element, how many elements are there? This is going to be order n into n. Right? There will be one loop which will run from 0 to n. Then there will be another loop inside that which will run from 0 to n. Right? Okay. Now some of you are saying that you can solve this problem using binary search. Now, for all those who don't know how binary search works, you can just skip this part. We will be covering binary search in details in the upcoming classes. For all those who know how binary search is going to work, can you guys quickly think of an approach which uses binary search? See, all the rows are sorted. Okay. If all the rows are sorted and you have to search an element in sorted rows, can you use the fact that the rows are sorted? Yes. So in each and every row, you can apply binary search, right? What is the time complexity of doing binary search on an array of size n? If you are running binary search on an array of size n, the time complexity is log n, right? And if you are doing binary search in all the rows, how many rows are there? So in this case, we have n rows and the size of each and every row is m, right? So in our case, if we apply binary search on every row, if you apply binary search on each and every row, what will be the time complexity? There are n rows and there are m columns. So there are m elements in each row, right? So this is going to be the time complexity. Okay, cool. Can we do better? Okay, if we want to do better, let us try to make some quick observations. Okay, if this is the matrix, let's draw a matrix here. Where can we find the smallest element of this matrix? Can you guys quickly tell me the coordinates of the smallest element present in this matrix? The smallest element of this matrix is going to be at 0, 0, right? This is the smallest because all the rows are sorted, all the columns are sorted. So this is the smallest of all. Where can I find the largest element of this matrix? The largest element of this matrix is correct. It's going to be at the cell n-1, n-1. This last cell, right? This is going to be the largest of all. Now, if the target element is smaller than 0, 0, or if the target element is larger than this element, can I directly say that that element is not going to lie inside this matrix? If your target is less than 0, 0, or your target is greater than the last element that you have, which is present at n-1, n-1, can we say that this target is not present in the matrix? Yes. What if this is inside the range? What if the target is inside the range? So if we are starting from this point, if the target is greater than 10 and it is less than or equal to 71, and I'm starting my search from this point, can the target be present in this row? If it is greater than 10, can the target be in the first row? Yes, because all the elements of this row are greater than 10, right? So target can be 30, it can be 40. Target can also be 17 or 15, right? So it can also be present in this column as well. So if the target is greater than 10, it can be present anywhere in the matrix, right? If we are starting the search from here, we are unable to make any conclusive decision, because all the elements here and all the elements here are following the exact same property, which is that they are greater than 10. So this is not allowing us to discard any of the search space, correct? Let us start the search from this block. Now, if the target is smaller than this, can I say that the target has equal chances of being present in this row, in this column, as well as in the last row? Because all the numbers in this column are smaller than 71, because the column is sorted in ascending order, right? All the elements of this row are also smaller than 71. So again, we don't have any decision that we can take, right? We cannot discard any part of the search space. All the values are still relevant. Okay. Let's try to search from this point. Now, can you guys figure out a pattern? If I'm standing at this point, if I'm standing at 50, what can I say about all the elements present in the first row and all the elements present in the last column? If this row is sorted in ascending order, can I say that all the elements of this row are going to be less than 50? Similarly, all the elements of this column will definitely be greater than 50. Is it going to help us make any decision? So if the target is less than 50, can I say that target will never be present in the first column? If the target is less than 50, the column is sorted in an ascending order, right? If the target is less than 50, all the elements in this column are definitely going to be greater than 50. So the target will never be present in this column. Now I am able to make a decision to discard some part of the search space. The search space has become smaller, right? All these values are now irrelevant. Okay. So if the target is less than 50, I can directly move to this cell and I can start comparing from this cell. Now, if the target is greater than 40, can I say that that target will never be present in the remaining part of this row? If the target is greater than 40, I know that all these elements are less than 40 because the row is sorted in ascending order, right? So now these elements become irrelevant for us. So I can discard this complete row. Okay, and now I can start my search from this cell which has 45. Again, I can check whether the target is smaller than 45 or greater than 45. So at every step, I am able to make a decision of either discarding one row or discarding a column. So let's say that if the target that we have to find is 26. Okay, if 26 is the target that we have to find, at this step, I know that 26 is smaller than 45, and since this column is sorted in ascending order, all the elements below 45 are useless, right? 26 can never be present in this part because 26 is smaller than 45. So I will move my pointer to 35, right? Now, when I'm at 35, I know that again, 26 is smaller than 35. So all the elements of this column also are useless for us. Okay. So we move to 25. If currently I'm standing at 25, I can see that 26 is bigger than 25. If 26 is bigger than 25, all the elements present here are useless for us, right? So we move down. Now, when we move down, we figure out that this element is nothing but the target. So we have found the target. So in every step, we are either able to discard a complete row or we are able to discard a complete column. So you will be running a loop. You will be starting from the topmost corner, right? You will be starting your code. You will be starting your search from this top right corner. And you can say that if this element is equal to the target, then you can directly return true. Or if you are asked to return the coordinates, you can do that. Now, if this element at the top right corner here is smaller than the target, then what can we say? We can say that all these elements are if this element is smaller than the target, then these are useful, but these elements are useless because these all elements will also be smaller than the target, right? So what can we do in this case? We can just switch to the next row. So we will be doing I++, okay? Else if this is greater than the target, then what can we do? If this element is greater than the target, then all these elements will also be greater than the target. So we can switch the search space, or we can switch the column to the previous column, right? So we can move to the previous column. So that will be J minus minus, okay? And there will be a while here. Can you guys tell me what should be the condition which should come here when we have to stop all these things, when we have to stop the search? If we find the target, then we are returning. So that will obviously break this while loop. But what should be the condition? What should be the boundary cases for this search? We're starting the initial I value from where we are starting is 0, right? This is the first row from where we are starting. The initial column value is the last column, which is m minus 1. So these are the initials from where we are starting. Now what should be the restriction, or what should be the boundary where we can go? This I. So now you can also pay attention to how we are changing these variables, right? So I is always getting incremented, j is always getting decremented. I is currently at the smallest possible value, which is 0. J is currently at the largest possible value, right? So if you are incrementing I, you have to make sure that you are not going out of this matrix from here, right? So I should always be less than n, okay? And if you are decrementing j, you have to make sure that j does not become less than 0, right? So j should always be greater than or equal to 0. So this is your boundary case till which you have to run this loop. And if you find the target, it's good, return true. If this current element is less than the target, all the elements of the first row will also be less than the target. So ignore them, move to the next row. If this element is greater than the target, then all the elements of this column will also be greater than the target. So ignore them, move to the previous column, okay? And we search the element. What is the time complexity? Some of you are saying log of m into n. Is it log? What is the time complexity? So to get to the time complexity, focus on what is the maximum number of steps that you are going to take, right? What is the maximum number of values that I and j can take? I is starting from 0, it can go till n. J is starting from m minus 1, it can go till m. So what is the total number of combinations of these values that can be there? In every in other terms, you can also think in this way, that in every step, either you are ignoring one row or you are ignoring one column. There are total n rows, there are total m columns. If in the worst case, if the target that you are finding is present here, you will be ignoring all the rows above this and you will be ignoring all the columns after this, right? So the time complexity is going to be n plus m. What if matrix is not sorted? If the matrix is not sorted, you cannot apply this logic, right? Why not maximum of n and m? That is because you can do both of the things, right? If you are moving from this corner to this corner, you will have to take all the n steps in order to move from here to here, and you will also have to take all the m steps in order to move from here to here. This is the worst case, that you go down as much as possible and you also go left as much as possible, okay? So that is n plus m. of every row. Okay, Vijay, if you can just try to see some of the example, just try to dry run your approach on this matrix itself. You will find that chances of finding your element in every row will be there. So if let's say I am talking about if I have to find 30 is smaller than all these numbers, right? So 30 can be present in any of the rows. 30 is greater than the first number of all the elements in the first column. 30 is less than all the numbers in the last column. So 30 has got a chance of being present in each and every row. So you will have to apply binary search in every row. And if you are applying binary search on each and every row, then that will be n log m. Pseudocode, we have written the pseudocode, right? This is the pseudocode. Or this is the actual code, not the pseudocode. This is how you are going to initialize your I and j, I from 0, j from m-1. Okay. And I hope you have learned something in today's class. Please do solve the problems and please do subscribe to the channel so that you don't miss any new class update. Okay.